Planet! Hack the planet! Shut up again!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs, it's me, the Shy Hat. And what are we doing today? Well, we've got a humdinger of a stream for you today. And let's talk about the different things we're going to be talking about. As usual, we've got our schedule over here on the HackerFrogs subreddit. And if you want to take a look at where that is, it's just over here. I've provided to everybody in the chat. And we're going to be covering the following 4 topics in stream today. So the first topic for today is going to be HackerFrogs After School Network Hacking, extra session number 1. So what we're going to do is we're going to be doing a capstone project for network hacking, and we're going to be taking a look at the Try Hack Me Room basic pen testing to do that. So that's going to be in the first hour of today's stream. In the second hour of today's stream, we're going to be taking a look at the Temperance CTF over at HackMyVM.eu. This is a CTF lab where you have to do some programming in order to get the flag from the server, and it's going to be a good test of our Python writing skills. That's going to be in the second hour of today's stream. In the third hour of today's stream, we're going to be taking a look at the stack-based buffer overflows on Linux x86 module over at HackTheBox.com. So HackTheBox.com has a large education component to it. It's called Hack the Box Academy, and we're going to be learning about binary hacking through this room over here. So please look forward to that. That's going to be in the third hour of today's stream. And in the fourth and fifth hours of today's stream, we're going to be doing some labs over at the echoCTF.red website. And this is a fun cybersecurity platform where you can learn about all sorts of different hacking topics. It's kind of similar to sites like TryHackMe and HackTheBox, but it's a little bit indie, and it feels pretty good to do the challenges over there. So please look forward to that, and let's go ahead and get started with the first topic for today's stream. That's going to be network hacking extra session number 1. So what are we going to be doing today? So it's going to be a little bit more freeform than usual for this HackerFrogs After School session. We're going to be covering this room over here. I'll just copy the link over to everybody in chat. And we're going to be doing this room over here. We're going to be going over it slowly, and we're going to be talking about all of the different commands that we're going to be using to do this particular CTF box exercise. So let's see. I think this is still running for me. I'm going to terminate this. I'm going to restart it in a bit. And I think I'm going to reset my progress on this room so that I can show everybody what the room looks like when you first come upon it. So let's go ahead and leave. So to do this, to follow along with our exercise today, what you're going to need to do is you're going to need to have a registered account over at tryhackme.com. And if you don't have one, you can make one for free at this link over here. So what you need to do is you need to log into the tryhackme.com website, and then you need to go over to the link that I provided to everybody in the chat. So this is the basic pen testing room. And we're going to combine all of the skills we used in the network hacking course over the last 10 sessions or so. And we're going to be doing this box, and I'll be explaining what we're doing each step along the way. So the first step to do this is to go ahead and go to the link, and then you're going to see this. WX Rob is just rated the channel with 45 viewers. Hello, Raiders, and hello, Rob. Nice to see you here. Wow, raid. Hi, everybody. My name's the Shy Hat, and I do cybersecurity education over here at twitch.com and over at youtube.com as well. Welcome, Raiders, and if you want to join in along with us, what you can do is you can go over to this link over here at the tryhackme.com website, and you can go over to the basic pen testing room over here. We're just about to start this, and while we do this room, we're going to be explaining everything that we're doing. Okay, Rob says, gotta run before IKEA closes. See ya. See you later, Rob. And what was Rob getting up to on his stream? Let us know. Thank you very much. Were y'all doing some fun stuff over there? Okay, so let's go ahead and join the room. So log into your TryHackMe website, and then go over to this room over here. Kubernetes and Ansible. Not something I know very much about, but it's something I definitely want to learn more about. Christy E. I'm not too sure. Hello, nice to see you here. And Lopsided Pixel, hello, welcome. And thank you very much for following Forties Gamer. Thank you. Okay, so click on the Join Room button, and then you're going to have access to all the stuff inside this room. So you can access the room for free. None of the stuff that I cover is paid. So you can access the TryHackMe room for free. You can access the TryHackMe website for free. It's fine. And thank you very much for following Christy E. and Easy Z. Thank you very much. Let's give everybody a fun video redeem. How about a Nyan Cat? Whoops, that's not how you spell that. And good night, Fixit42. Nice to see you here, and have yourself a great night. Okay, so in the previous 10 sessions or so on the stream, we've been going through a network hacking course, and we've been learning about how to do these CTF exercises. So this is kind of a capstone exercise for the entire course. And under task number 1, it says here that we're going to be learning the following things. We're going to be doing some brute forcing attacks. We're going to be doing some hash cracking, some service enumeration, and some Linux enumeration. So this is what we're going to do. We need to start the machine that's associated with this room. So under task 1, on the right-hand side of the screen, you're going to see this green Start Machine button. Go ahead and click that. That's going to start up the vulnerable machine that we're going to be attacking in just a little bit. And afterwards, we need to start one more machine that we're going to be using to interact with this room. We can interact with the room by connecting to the TryHackMe network via OpenVPN, but for us beginners, what we're going to do is we're going to access the room via the TryHackMe attack box. So to access the TryHackMe attack box, you can go up to the top of the web page, and underneath the icon for basic pen testing, you're going to see this button over here labeled Start Attack Box. Go ahead and click on that, and then you're going to see that the attack box opens up in the right-hand side of the web page. So it's going to take a couple of minutes to initialize, but after it's finished initializing, we're going to have a security distribution of Linux that is accessible from the cloud that we can use to attack the machine that we're testing today. So that's just going to take a couple of minutes, but let's talk a little bit about what we're going to be doing to enumerate and to complete the exercise today. So the first thing we're going to do is we're going to scan the target machine for open ports, and we're going to be doing that with the nmap command. Nmap is a very common tool in security testing, and it's something that everybody needs to learn how to use if you want to do some network security testing. But let's see. So what else are we going to be doing here? So we don't know what exactly is on this server located over at this IP address. And see, Paulo Troll says, I think the attack box is taking longer to load because there's a CTF going on in TryHackMe. Thank you very much for telling me about that, because I didn't really know that everybody was using the resources over at TryHackMe. But yeah, it might be a little bit slower than usual. I noticed a little bit earlier today that the VPN connection was actually kind of slow. So I think I think the connection might be a bit spotty today, but hopefully we can make it on through. Okay, so we've got our attack box. It is initializing over here, and I highly encourage anybody who wants to go ahead and follow along with us, because, well, I mean, these demonstrations are meant to be hands-on, and there's nothing better than getting hands-on with a concept to help you learn. Okay, so now that our attack box is finished initializing over here, this is what we're going to do. We're going to click into the terminal here, and then we're going to hit enter to dismiss this message. And so what is the attack box? The attack box is a Linux virtual machine that has all sorts of great security tools installed on it. And well, right now it's a little bit cramped. What we really want to do is we want to put this in full screen. But before we put this in full screen, there's one thing we want to do. We want to record the IP address in one of our terminals, because we're going to be referencing the IP address for the target machine quite a bit. And so what we're going to do is we're just going to go up to the top of the attack box interface, and then over here on the right hand side of the desktop, there's this terminal shortcut over here. We're going to click on that. And then we're going to see that we've got a terminal over here, and we're just going to type in the IP address for the target machine in this terminal. So, well, why we do that is because we're going to be using this IP address a lot. So it's going to be 10.10.47.227. Your IP address is probably going to be different from my IP address. Please put in your IP address when you type into the terminal. Okay, so after that's done, what we're going to do is we're going to make the attack box terminal nice and big, and we're going to put it in its own browser tab. So we can do that by going over to the center of the screen, and then down to the bottom, there's this button over here that's labeled View in Full Screen. Well, we want to click on that, and then after that, we're going to see that the attack box desktop interface is now in full screen. This is what we want. Okay, so let's go ahead and, well, I'm going to make the terminal nice and big so that everybody can see it much better. Because if you can't see what I'm doing, then that's a problem. All right, so the first thing we're going to do this exercise is we're going to scan for open ports and services on the target machine. And the target machine is this IP address. So the command we're going to use is nmap, and then we're going to scan all of the open ports, and we're going to scan for the versioning information for whatever services we find. We're going to scan very verbose, and we're going to scan very fast. So this is the full command right here. Let me copy that over, and I'll provide it to everybody in the chat. So if for some reason there's anything that you don't understand about what we're doing today, please let us know in the chat. We'll try to answer your questions as best we can, because we don't want anybody to feel like they're being left behind. So as usual, you're probably going to need to substitute out this IP address with your own IP address for the target machine. So when we run nmap, we're going to reach out to the remote server, and we're trying to figure out what open services and ports are on the remote system. Okay, so immediately we find that there are 4 ports open on the system, and these ports are all associated with different services that are being served by the remote server. So for example, port 22 is associated with the SSH service, and okay, we get this back. So this is port 22, it's associated with the SSH service. This is remote login, and this lets users log into the system remotely. So the SSH service is usually not vulnerable to any known software hacks, not unless the version of SSH being used is very, very old. So port 80 over here, we also found this, and this is serving a web page. So port 80 is associated with the HTTP protocol, which is unencrypted web pages. And we might want to do some enumeration on the web port a little bit later. There's also port 133, 139, and 445, which are both associated with the SMB service. So the SMB service is a file sharing service, which is very commonly associated with Windows machines, but it can be served on Linux machines as well. So we can also do some enumeration against the SMB service to find out what files exist on the file server and what users also exist on the server. Okay, so what are we going to investigate first? So probably the easiest thing to investigate first is the web server over here. So the web server is at this IP address right here. Sorry, at port 80 over here. And what we're going to do is we're going to run a command that's going to enumerate the web server. So when you want to access HTTP, you would normally access it like this. So it's HTTP:// and then the IP address. So what we're going to do is we're going to run a very simple web enumeration tool called derb. So derb is going to reach out to the web server and try to find out what files and directories exist on the website. So when we run the command, well, let me go ahead and get the command that's being used here, just in case you want to use it yourself. Okay. So we see here that we found a couple of different endpoints. So we found the development endpoint here, we found index.html, and we found server status. Well, we didn't really find server status. It really depends on the response code that's given to us. So 200 means okay, and 403 means, I think it means forbidden, which means we really can't access this. But we also found this development endpoint over here. This is a directory. And what we can do is we can use the HackTheBox web browser to take a look at this. So we can highlight this and copy it. And then we can open up the HackTheBox's web browser. So the HackTheBox, well, we're accessing the HackTheBox via a web browser, but we can also open up a web browser inside of the HackTheBox. And the way we do that is by going over to the right-hand side of the screen. There's going to be this Firefox web browser shortcut. Click on that. And after a few moments, we're going to see the web browser open up. So what we want to do is we want to access the link that we just copied in the web browser. So the web browser's here. Let me go ahead and click on the address bar in there. We're going to paste it in. And then we're going to hit enter. Okay, so in this, let me make this a little bit bigger. So on this website, in the development directory over here, we see that there are two files. There are two files that are available to us. We're going to click on this, the second one over here. That's called j.txt. Okay, so we see a little note here that's being addressed to J. We don't know who J is, but the message is this. I've been auditing the contents of the etc.shadow file to make sure we don't have any weak credentials, and I was able to crack your hash very easily. You know our password policy, so please follow it. Change that password ASAP. So this gives us an indication of what is going on from a security standpoint on the server. So the user J apparently has a weak password that is cracked very easily, and they did this by auditing the contents of the etc.shadow file. The etc.shadow file in Linux is where all of the password hashes are kept. So the passwords themselves are not kept there, but the hashes that are created after the password is transformed are. So we will be doing some password cracking a little bit later, but for now, we just need to note that the user J has a very weak password. Okay, so the next thing we're going to do is we're going to be enumerating the SMB service. So we're just going to minimize the Firefox browser over here, and inside the terminal, we saw that there was port 139 and 445 available on the server. So these are associated with the SMB service, which is a file sharing service. We can use this tool over here called enum for Linux. And what was that IP address? This is the IP address. Okay. So we can use the enum for Linux tool to enumerate the SMB service on the remote server. So let me just get the command. I'll provide it to everybody in the chat, just in case you want to use it. So what enum for Linux is going to do is it's going to reach out to the SMB service, and it's going to try to get a bunch of different information from the server about the SMB service, and it's going to return it to us. So when we run the command, it's going to give us a lot of information, and If you think that it's a bit hard to read, then I understand, because you need to learn how to read the output of these different tools. So for example, let's see. So I was able to figure out that there's an anonymous file share on the system. So it says here share name anonymous disk, and it also says attempting to map shares on this IP address. And the anonymous share mapping is okay, listening is okay, which means we can enter this file share without providing a valid username and password. But in this case, we're not going to be doing it because there's a much juicier thing present, and I'll point that out in just a couple of moments. Okay, so what else do we get from the system? So the system tries to enumerate usernames on the system by going over a series of numbers. So these are called SID numbers, I think they're called. And down at the bottom over here, it says enumerating users using SID and login, username blank and password blank. It finds these three local users on the target. So it finds K, it finds Jan, and it finds Ubuntu. So these are all names of users on the system, and what we can do is, well, we discovered that a J user on the system has a very weak password, and what we can do is we can try to brute force this user's credentials on the SSH service. Since we know that Jan has a weak password, according to the note that we found on the web server, we can try to brute force, and since we found Jan's username by enumerating the SMB service, we can try to brute force Jan's SSH credentials. And this is how we're going to do it. So we're going to run a command called Hydra. And I forget how to use, the Hydra command is a little bit, it's a little bit complex. Let me see if I can recall how to do this. Okay, so it's going to look something like this. And I'll provide the command to everybody in chat as well. Okay, so unfortunately in the attack box, what you need to do is you need to open up this little clipboard that you can access from the center of the screen on the left. And I'm going to paste in my Hydra command over there. So let's see, the Hydra command, let me paste that in. Okay, so it's going to be Hydra L and then Jan, which is the username that we're going to try to brute force. The next thing we need to do is we need to do a -P and then provide the name of the word list we want to compare for the attack. In this case, we're going to use the rocku.txt file, which is a pretty commonly used file in security, and it contains 14 million of the most common passwords. And the next thing we're going to do is we're going to specify a number of threads, because the more threads we use, the faster the task is going to go. And in our case, we specify 64 threads. And the last thing we do is we supply the IP address along with SSH as the protocol. So this is the command right here. When we run the command, we're trying to log into SSH, but we're trying to brute force all of the passwords in the rocku.txt file, and we're specifying that we're trying to log in as the Jan user. So this can sometimes this kind of brute forcing attack can take a very long time, and that's why most of the time we don't like to do brute force attacks first, unless we don't have anything else to do. But in this case, there's not too much else we can do, so we do our brute force attack. So another thing to consider with brute forcing, with the SSH protocol in particular, is that sometimes, well, these days, more and more often, the SSH service also has brute force protections in place. And brute force protections will make it so that your IP is going to be banned by the remote server after incorrectly logging into SSH more than a certain number of times. It's usually like 5 times or so. Okay, so we just need to wait for this to come back to us. Not too sure exactly how long that's going to take. So once again, we're trying to brute force into the server by providing a username, which is Jan, and then all the passwords in the Rocky list. So we managed to find a credential, a pair match. So we got Jan as the login name and Armando as the password. So that means what we're going to try to do is we're just going to try to log in as this user with this password over here. So the command is just going to be ssh jan at IP address 47. Okay, just like this. So the SSH command syntax is not very complicated, which is nice. So when we try to log in with SSH, and we know that the SSH service exists on the target because we were able to find it using the nmap command. Do we want to continue connecting? Yes. When they ask us for the password, we're going to use the password that we were able to brute force, and that's Armando. Okay, and now we're logged in as the Jan user. So we ask, who am I? We are Jan. Okay. So from here, we've gotten our initial access to the remote server as the Jan user, and what we want to do now is we want to look around and we want to elevate our privileges. So this is called privilege escalation, and it basically means that we need to snoop around inside of the Linux file system to try to find something that's vulnerable. So we saw that there's a Jan user and a K user. So Jan is our user, K is the other user. If we move into K's directory, we can read the files in there. So inside of here, there's a couple of juicy files. So this looks like it might be a backup password file, but unfortunately we don't have permissions to read that file. If we take a look at the file permissions here, global users don't have read access, and only the file owner has read access, which means that we can't access this. But there's actually something else that's very important in this directory, and if anybody can identify what is the important thing that we can read in this directory, let us know. So just type in the chat and let us know what you think might be the critical thing that we need to take a look at. If your answer, Sigma says the bash history file. So I mean, the bash history file has a list of all the bash commands that were run by that user, and it is very useful to look at. But unfortunately, we don't have read access to the file according to the list over here. Paulo Troll says SSH maybe. Yeah. So in this case, it's the SSH folder. So the SSH folder in a user's home directory is usually, well, it might have some SSH keys inside. So SSH private keys, SSH public keys. SSH private keys are used in the place of, hold on, we've got ads running on Twitch. Okay, when ads run on Twitch, I also run them on YouTube. Here you go. And we're gonna put on some birds so that you can so that we can all enjoy the birds while the ads are running on Twitch and on YouTube. So let me go ahead and get one of these bird videos. How about this one? Okay, so enjoy the birds and enjoy the little break. We're going to be back in about 50 seconds. Okay, let's put the birds away and let's get back to the hacking. So sudo adds admin successful seems interesting also, says Paulo Chol. Yes, that certainly does. So we suspect that that K is an administrator because they're able to use sudo as the administrator. Well, or to sudo, yeah. So another thing we're going to do is we're going to be taking a look at the SSH key over here. So SSH private keys, a very common name for these keys is ID_RSA. And if we can read this key, we can potentially steal the key and log in as the K user. What we can do is we can copy all of this. So we read the file. We're just going to copy the entire key up until end RSA private key. We're going to write this to our HackTheBox directory. So we're just going to select copy, and then we're going to exit from the server. So from here, just type exit, and then we're logged out of the server. So after that, we're back on our HackTheBox. We know because we're the root user on the HackTheBox. We're going to nano and create a file called ID_RSA. And then after that, we're going to paste in the contents of the ID_RSA private key. So now we have our own copy of the ID_RSA private key for the K user. So to save this file, we do Control-X, save modified buffer Y for yes, hit enter to confirm the file name. Okay, so there's one more thing that we need to do before we can use this key to log in as the K user. So let me point this out. Actually, let's... Okay, so this is the file we're looking at here. There's something wrong with the permissions for this SSH private key. We see here that global users can read the file. Global users can read the file. Anybody in the same group can read the file. And these are no-nos. So you have to make it so that the file permissions for these SSH private keys are such that global users cannot read or write or do anything to the file. Same thing with the group users. So this is what we're going to do. We're going to use the chmod command to create the correct file permissions for this file. So in this case, it's going to be considered 600. 600 means that only the file owner can read and write to the file. And we specify the file in question, which is ID_RSA. And after that, we should be able to try and use SSH as K at the IP address. What was the IP address again? This is the IP address. So we're going to SSH as K. And we're going to specify that we're going to use the ID_RSA key to log in instead of a password. So it's going to look like this. Okay, so when we run the command, it's going to ask for a passphrase for the key. So, So SSH private keys can have passphrases. So passphrases are kind of like passwords, but they're only for the key. And since we don't know what the passphrase is, we can't answer this question. So it asks us for the password instead, and we don't know the password. So we can just Control-C to get out of this command, and what we're going to try to do now is we're going to try to figure out what the passphrase is for the ID_RSA key. So how do we do this? So there's a certain command or a certain tool that we can use for password cracking. And password cracking is basically trying to figure out what the password is for a particular offline file. So the difference between brute forcing and cracking is that one is done on an online service. So brute forcing attacks are done against online services, and cracking attacks are done against offline services, or against offline hashes rather. So this is what we're going to do. So we're going to use a utility called ssh2john, And Error, hello, nice to see you here, Error. And yeah, welcome to the stream. Error on YouTube, thank you for coming by. So we're going to use a tool called SSH2John to create a file hash out of the IDRSA file. So we're going to run SSH2John on IDRSA, and we're going to output it to a file. We're going to call this key.hash. So Error says, sorry for the intrusion, but have you created a video on salted hashes? So video on salted hashes. I think I did a network hacking session on hash cracking. So I think that was let me go ahead and grab that from my YouTube video, from my YouTube channel. Just a second. I should be able to find it pretty quickly. So I've got my YouTube channel, I've got all of my previous live streams here. Let's see if I can get this previous live stream for my friend Error over here. So network hacking, reverse shells, password cracking. Okay. Yeah, so you can go ahead and take a look at this live stream link. Heffel Husky, hello, nice to see you here, and welcome to the stream. Okay, so what were we doing? We're doing something at TryHackMe, right? Yeah, okay. So SSH2John, I think SSH2John on the attack box is a Python script. So I'm gonna try locating it. Okay, here it is. Alright, so which Python are we using? So there's Python right there, okay. So we're gonna run, is this Python 3 or is this Python 2? I'm not too sure. I think I'll just use Python anyways. So this is the script over here, SSH2John. And for everybody who's working on the attack box, I'll provide everybody with the exact command we're doing over here. So before I provide it to everybody in chat, I just want to make sure that this works. Okay, so that worked. So this is the command I used. Oops. Should be this. Okay, so after we run the command, we should have extracted the hash from the IDRSA file over here. So if we take a look at key.hash, this is the file, this is the password hash for the IDRSA key. So what we're going to do is we're going to use a very common security tool called John the Ripper to crack this hash. So we just need to do John and word list equals user share word lists rocku.txt on IDRSA. Oh, sorry, not IDRSA, it's key.hash. Okay, so let me just make sure that this is the correct command before I give it to everybody in chat. So we're using John the Ripper, and John the Ripper is a program designed to crack password hashes. So we give it a hash, and then we give it a word list that it has to compare against. And it's going to try to figure out if any of these passwords match the hash that we give it. So, okay, so okay. So this is the command we used right over here. So it says over here that that this is the hash for the key.hash file. So it's beeswax. So we figured out that the IDRSA private key, or the SSH private key rather, has this password right here, so beeswax. So we're just going to run the SSH command again, now that we've figured out what the password is for the IDRSA key. So it's SSHK at this IP address -I IDRSA. So it's going to ask us for the passphrase. We know the passphrase now. It's beeswax. So beeswax. And now we're logged in as K. So inside of K's home directory over here, there's this password.back file. So we suspect this is backup password, and we can go ahead and read that. So what we found here was that there's a password in here. So here's a really strong password that follows the password policy $. What we're going to do is we're going to try to figure out if K is actually an administrator, because it says sudo as administrator successful here. We're going to find out what sudo permissions they have on the server. So sudo L is going to let you know what commands you can run as the root user. It's going to ask for the password to K. We're going to paste in this password here. And it's going to give us this answer here. So user K may run the following commands on this server. So as any user, as any group, you can run any command, which basically means that K can become the root user. So K can become the root user by doing this. So sudo su, this is going to try to become the root user. It's gonna, oh, okay. And we just become the root user. It doesn't ask us for the password because we already put in the password in the last, I think it's a minute or so. I'm not too sure what the timeout is for using sudo commands. But if you use sudo commands, if you use multiple sudo commands within a time frame, I think it's like 1 minute or 2 minutes, then it doesn't ask you for the password on the subsequent commands. Anyways, we're now the root user. So who am I? We are the root user, and I guess we can do this.
What are you?
I'm system root.
So yeah, we're the root user, and we managed to do quite a few things during this exercise. And let me point out a couple of them. So the first thing we did is we ran an nmap scan. So the nmap scan is used to figure out which... let me get out of here. Actually, you know what? I think I'll open up a new tab in the terminal here. Okay, let's make it nice and big. Whoops. I closed out everything. I didn't mean to do that. Okay, so the first thing we did was we ran an nmap scan on the target, and when we did that, we were able to figure out which open ports were available on the target. We found HTTP, and we found... let me go ahead and grab the IP address really quick so I can demonstrate one more time. Okay, so we were able to identify these 4 ports right here. So after we identified the ports, we were able to investigate those ports. So we tried to investigate port 80, which had the web page, and we also investigated the SMB service over here. So through investigation, we found that one of the users had a weak password, and we were able to figure out what that username was, so we did a brute force attack. After we did a brute force attack, we logged in as that user, and then we found a SSH private key that was readable by everybody, which is a security misconfiguration. And then we copied the file over to our own machine here, and then we cracked the password for the key. After we did that, we were able to log on to the target as the administrator, and then become the root user. And that's how we finished the exercise. But yeah, let's go ahead and answer some of the questions over here on the Try Hack Me page. So on the Try Hack Me page, we can answer these questions over here. So deploy the machine, connect to the network. Okay, that's done. It says unauthorized. Oh, are we not logged in? Let me try reloading this page. There's something wrong. Hello, hello. Ronan, can you hear me? I don't think my mic is muted. Hi everyone. Can you hear me? Is my mic muted? Okay, it looks like I'm not logged in, so I need to log in again. Okay, let me log in again. Okay, great, great. Somebody reported that they couldn't hear me. Okay, we're looking for motorcycles. Is that a motorcycle? Is that a motorcycle? Okay, let's. So we're logged in now. Let's go ahead and answer the questions. So let's see. Deploy the machine, connect to the network. Are we not joined? I thought we joined this room. Okay, so let's see, complete. So deploy the machine, connect to the network, that's done. Find the services exposed by the machine. There might be some problems with Try Hack Me because, well, somebody reported that there's a CTF going on, and that means that the Try Hack Me pages might be a bit slow today. So find the services exposed by the machine. So we used Nmap to do that. Scary Hacker Man approves. Scary Hacker Man might make an appearance later today. So let's see, what is the name of the hidden directory on the web server? Enter the name without a slash. So we found there was a development server or a development directory on the server, so we can submit that. Okay, so it says user brute forcing to find the name and password. So we did the user brute forcing, we can complete that. It asks what is the username? So the username that we found that had the vulnerable password was the Jan user. Amari, hello, nice to see you here. Welcome to the stream. And let's see, so for Jan, what was their password? The Jan user's password was Armando. So we can submit that as the answer. And it says, what service do you use to access the server? Answer in abbreviation in all caps. Answer in abbreviation in all caps. So which service do we use to access the server as the Jan user? That's gonna be the SSH. That's gonna be the SSH server. It says enumerate the machine to find any vectors for privilege escalation. So we found a insecure SSH private key, and we use that for privilege escalation. Okay, so what was the name of the other user that we found in all lowercase? That was the K user. And it says, if you found another user, what can you do with this information? So if you find that there are other users on the target when you do your initial access, you can use those users for lateral privilege escalation. So lateral privilege escalation means not becoming the highest level user, but another user, rather. So that's the answer. And what is the final password that you obtain? So we're just going to go back and we're going to get that password one more time because the password's kind of long, and it's SSH K at, what was that? Yeah. So SSH K at this IP address with the ID RSA key. So we cracked the password, and the passphrase for the key was beeswax. So let me get that password one more time. Okay, so we're just going to copy that. Okay, then we're going to go back and provide that as the answer. Okay, we finished. We finished the room. And I didn't notice before, but Kiss Killer 0, welcome to the stream. Hello, nice to see you here. Okay, so we finished the room, and what we're going to be doing next time is we're going to be doing one more capstone exercise to try to figure out some more about this basic pen test stuff. So please look forward to that. That's probably going to be on, what day is it today? It is Friday. It's Friday, TGI for everybody. We're going to be doing that on Monday of next week. So please look forward to that. And with that, let's go ahead and, well, let's finish out today's lesson. So what are we doing next? So we just did topic 1, network hacking extra 1, and we're going to be moving into our Python programming. Sigma says, made light work of that room. Well, I mean, the room is designed to be a basic test, and we're just trying to put together all the skills that we learned during our network hacking course. But anyways, so the next thing that we're going to be doing on stream is we're going to be doing the HackMyVM.eu temperance labs. And if you don't know about those, they're located over here. What we're going to be doing is we're going to be doing some Python programming. We're going to be using our Python programming skills to solve some challenges. And I've been recording all of these. We're going to be starting at level number 13 today. Let's see if I can grab that. So HackerFrogs has a really big GitHub repository, and the HackerFrogs GitHub repository has all the stuff that we work on the live stream. So for example, we got my HackMyVM, we got the labs, we got the temperance labs, and we've got all the scripts that we've written to complete these levels inside of these labs. Okay, Error says, are these tools Nmap Burp Suite also the very basic ones that you use in professional pen testing, or do you use various other tools, especially for more robust secured systems? So Error, the answer is some of the tools that we use are some of the tools that we use in these examples, in these demonstrations, are the very same tools that we use in professional settings. So you'll find Nmap used in professional settings. You'll use Burp Suite used in professional settings. But there are other tools that are more specialized. You'll find specialized tools that are used in professional settings as well. But I like to use tools that are either very easy to teach. And in most of the cases where I can, I try to teach tools that are used in professional settings as well. The Tasteful Thickness says, I think the basic suite is effective at very old systems. It's not what modern professionals in the field would use in 2025. I think the most important thing is not to get hung up on the tools, but the methodologies involved. So there's always going to be a new tool that's used for web app directory busting, for example, or port scanning. But it's more important to understand the basic methodology of doing this kind of stuff. But let's get on with the next part of the stream. Okay, so we've got these labs over here at HackMyVM. And in each of these levels, you need to do something different to get your answer, to get your flag. Let me go ahead and... Where is it? Oh, I need to log in. Okay, so these labs are going to be at the Temperance Labs. So for example, each one of these levels is going to have something a little bit different that you need to do to obtain the flag. For example, we're currently on this level. This is level number 13, and in this level you must receive a list of strings, you must sort them alphabetically and return the last string in the list. So these characters must be removed. Okay, so how do we solve this level? We need to write up a little script to communicate with the server and to receive the information from the server and to send information to the server as well. Previously, we've been using these scripts that we wrote over here, and each one of the scripts that we write, we tend to edit the scripts instead of writing new scripts because programmers are lazy, and while hackers are also lazy, they try to get away with doing the bare minimum of work that they need to do, and what we're going to do is we're going to use a previous level script and edit it. And if you want to take a look at the script that we're using for this challenge, it's going to be here. Okay, so I need to do YouTube intros and outros for these videos, for these labs as well, because eventually I'm going to need to create some fun YouTube content for this. So let me go ahead and do that. I need to set up my programming environment, I guess you could call it. Okay, so let me go ahead and talk about this. So I'm just going to split my terminals into two. I'll do two terminals. In the two terminals, I'm gonna set one up specifically to run Python, and the other terminal is going to be specifically for writing Python. Okay, so let's talk about this. Let's do our little intro. Where are we? Here. All right, everybody. This is a guided walkthrough for level 13 from the Temperance CTF labs over at HackMyVM.eu. So, what do we need to do in this level? So it says here that in this level, you need to receive a list of strings, and then you need to sort them alphabetically, and return the last string in the what? In the list. Okay, the characters square bracket left and square bracket right must be removed. So for example, you might receive a square bracket list of strings over here. You need to sort them out and then return the one that is last in the list, so alphabetically. How are we going to do this? So we've got our script from the previous level over at the GitHub. What we're going to do is we're just going to make a copy of it, and then we're going to paste it into our coding window here. So we're just going to modify the script from level 12 to fit level 13. Let's explain. So the script is going to import the socket module from Python, and the socket module lets you communicate with servers over arbitrary ports. So in this case, the server that we're going to communicate with is temperance.hackmyvm.eu, and the port we're going to communicate on is 9988. The first thing we do in the script is we create a socket object. So with socket.socket, socket.afnet, socket.sockstream as s.connect. So the object is called s, and we're going to connect with the object on the host and the port, which is this stuff over here. Next, we're going to receive some data by doing s.receive, and we're going to save that as the data variable. Okay, we've got ads running on Twitch. So we run ads on YouTube as well, and then we put on some birds. How about we put on the happy squirrel? Okay, so we're going to be back in about 30 seconds while the ads run. See? Okay, puts the squirrels away and get back to the hacking. So yeah, we save the data that we received from the server. With s.receive, we get 1,024 bytes, and then we save that as the variable data. Then we print the data, and we also print the receiving intro right here. The next thing we need to do is we need to send some bytes to the server to let the server know which level we want to access. And in this case, we want to access level 13. So we're going to send these bytes over here, level X13. We're going to receive the challenge, and that's where we're going to end it off. So we're going to just comment out everything else in the script for right now, because we're going to workshop the script. So everything up until this point, we're just going to make sure that everything works here. So with this portion of the script, we're going to save that out, and then we're going to run the level 13 script. Okay, I think we're in the wrong directory. Hold on. Let's try that one more time. Okay, so this is what we do. This is what we get from the server. So we're receiving intro, we receive some bytes, receiving challenge, we receive some more bytes. So these bytes are a list. So in a Python, well, this looks like a Python list. So in Python, a list is a bunch of stuff inside of these square brackets. So what we're going to do is we're going to save these bytes as a string. And the reason we're going to be converting from bytes to string inside of this challenge, because the socket object only knows how to send bytes. And bytes are different from strings in computer programming. And so the next step is to convert the bytes into a string. We're just going to comment this out, and we're going to convert these bytes into a string. So we'll know that it's a string because in the terminal here, we're not going to see this B, and that's the only difference. So we're going to write that out. We're going to run the script again, and then we get this message here. So these are the bytes converted into a string, and it's this. So the next thing we need to do is we need to remove these two characters right here. So this character right here, this character right here, so the left and right square brackets, we need to get rid of these characters. So that's the first character in the string and the last character in the string. So how are we going to do that? So the next section is going to be this. It's going to be removing the left and right square bracket from the string. Okay, so let's see. I guess we're going to call this the modified string. So mod string is going to be equal to data string. Hold on, I think my music stopped. I need to get my music back. Let me get that back. Okay, music's playing again. Let's continue. So the modified string is going to be the data string, but we need to do some indexing over here. So string indexing instead of Python, I think we're going to start from the second character, because the first character is this bracket. We're just going to omit that bracket by starting with the second character, which is 1 in string indexing, and then we're going to specify that we're going to stop before the -1 position in the string. So the -1 position in the string is the very last character right here, the closing bracket. And so if we just get this, then it should omit both of these brackets. We're going to print out a message like this. So printf, this is the modified string without the brackets. and we're going to print out the mod string. Mod underscore string. I think this, let me adjust the size of my window a little bit. Okay. Okay. All right, so let's go ahead and comment out everything else, and we will save this out. After we save it out, we're going to run the script again. Okay, so this is the modified string without the brackets. So we see here that it is the modified string without the brackets. So there's no left bracket, there's no right bracket. This is what we want. Okay, so what do we do next? So the challenge says, where are we? You must sort them alphabetically and return the last string in the list. So we need to sort the strings that we get alphabetically and return the one that comes last in the list. So how do we do that? We're going to call this sorting the list alphabetically. Is that how you spell it? I don't think that's alphabetically. I don't know if that's how you spell that or not. So if we don't know how to do something in Python, we can always Google search it. So let me try over here. We're going to search for, I don't know, Python sort lists alphabetically. So we'll probably get something from the AI because the AI is integrated into Google search now. Okay, so two primary methods to sort a list alphabetically. So it says use the sort method. The method sorts the list in place, meaning it modifies the original list and does not return a new one. So this, I mean, this works. This works for us. So let's go ahead and do that. So we'll just do mod string. Actually, wait. This is a string. This isn't a list. Okay, sorry. We're not sorting the list alphabetically yet. We need to do this step first. We need to convert the string into a list. So despite the fact that this looks like a list, in Python it's not a list. Yeah. So column master says split then sort, split then sort. Yeah. That's the so let's see. We're going to call this we're just going to call this a list. I guess we can just call this list. So list equals mod string dot split. So I'm pretty sure this is the method you use to convert a string into a list, and it's going to split up the items by the spaces. Let's print out a message. The message is going to be, this is the string converted to a list. Oh, list. We can't use the word list, right? Okay. We're just going to call this string list. So the string list is going to be, this is the string converted to a list. And we can give a line break, and we're going to print out the string list. Okay, and then we're going to comment out everything else. We're going to write that out, and then we're going to try running this. Okay, so this is the string converted to a list, and we see that we have a new list over here with a bunch of strings. So this is what we want, and the next step is to sort the lists alphabetically. So this is going to be string list, and we're going to do the sort method on it, and we're going to print a message called This is the sorted list. And we're going to print out string list again. Okay, let's see if that works. Whoops, I forgot to comment out everything else. We need to comment out everything else, otherwise there might be something in the code down here that makes everything break. Okay, write that out, then run it again. Alright, so this is the string converted to a list. Great. This is the sorted list. So it looks like it's been sorted. Yeah, that's great. Okay, so the last thing we need to do before we send this back to the server is we need to retrieve the last item in the list. So this is going to be retrieve the last item in the list. So, whoops. Okay, so the last item in the list is going to be string list element -1. So element -1 is going to be the last item in the object. In this case, it's going to be the last object in the list. And we're just going to call this variable last item. And then we're going to print out something. So print, this is the last item in the list. Sorry, I need to put in these colons to satisfy my OCD. Okay, and we're gonna print out last item. Okay, write that out, and then so this is the last item in the list. This works. Okay, so the last thing we need to do to finish the exercise is to convert the string to bytes and then send the challenge back. So this is a string, and with the socket object we can't send strings, we can only send bytes. So we need to convert anything that we want to send back to the server into bytes and then send it back. So bytes is going to be last item dot encode from UTF-8 into bytes. So this is going to be last underscore item dot encode. That's going to be bytes, and then this is the string converted to bytes. We send the challenge back, sending challenge, send the bytes, and then we receive the flag. Hopefully we receive the flag. We'll see what happens. Okay, so we got the entire script ready. Let's run it one more time. Okay, so it worked. What did we do? We received some information in the form of bytes. We converted those bytes into a string so that we could work with it over here. Then we modified the string so that it didn't include these brackets because they didn't want us to send back the brackets. And we did that, and then we converted the string into a list, and then we sorted the list. We got the last item from the list, we converted the string into bytes, and then we sent those bytes back to the server and received the flag, which is this. Okay, so all we need to do now to complete the level is copy that flag and submit it to the server. Where are we? Here? Okay. So submit that flag. It says you've submitted the flag successfully. We're done. Okay. Alright, so everybody, that was a guided walkthrough for level number 13 from the Temperance Labs over at HackMyVM.eu. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. We're not leaving, everybody. We're not leaving. It's just something I have to record for YouTube. Thank you. Thank you for understanding. Okay, let's move on to the next level. So, okay. What are we doing in the next level? So it says, in this mission, you receive a string and a character, and you must return the number of times the character is repeated in the string. Okay, so everybody, if you want to do these exercises yourself, you can do them at the following link over here. You're going to need an account over at HackMyVM.eu, but it is a pretty fun series of challenges, and it tests your ability to do some programming. If you're a person who does a lot of programming, it shouldn't be too difficult for you. But for us hackers, we don't do a lot of most hackers don't do a lot of coding, but the hackers who are good usually can do a good amount of programming. Anyways, before we start the next level, what I'm going to do is I'm going to record the method we used to solve this level. Okay, let's get out of here. Bash is the most useful. Bash scripting is also very, very useful, especially if you're working with a lot of Linux. But I think Python scripting might be more useful because Python scripting is system agnostic, which means you can run Python scripts on any operating system you want to. But let's take a look. So level 13, I'm going to save this out, because if you didn't document something, it didn't happen inside of cybersecurity. Let's do that over here. Okay, so this is level 13. I actually have a solution for level 13 here, but I'm going to replace it. Okay, so we got our new solution. We're going to commit those changes. Then we're going to move on to the next level. Okay, let's talk about the next level. All right, everybody, this is a guided walkthrough for level 14. From the Temperance Labs over at HackMyVM.eu. So in this level, what do we need to do? So it says here that the mission in this level, you need to receive a string. You will receive a string and a character. You must return the number of times the character is repeated in the string. So if we've got this really long string over here, and then after the string, we see the character X. And what we need to do is we need to write a script that is going to check this string for the number of times the X character appears. So in this case, that appears 9 times. And we need to return this number as bytes back to the server. So let's go ahead and figure out how to do that. Okay, so I'm just going to turn the script that we wrote for level 13, and we're going to turn it into level 14 scripts. Chill Crunch, thank you very much for following on Twitch. Welcome to the stream, and you're now HackerFrog. Let's give you a fun video redeem. Let's give you some... Jurassic Park.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
So did you know that back in 1993 they used Unix to save everybody from dinosaurs using Linux? Oh, sorry, it was Unix. Unix, of course. Anyways, let's continue on. All right, so we're gonna modify the script that we used for the previous level for level 14. So the first thing we need to do is we need to go into the script and we need to change it a little bit. So specifically here, it says send 13 to choose the level. In this case, we're going to change 13 to 14, and we're going to receive the challenge from the server, just like we did in the previous level. So we're just going to we're going to comment out everything that happens after this step in the script, and we're going to make sure that everything is being run correctly. So this is, I mean, I'm not too sure what the terminology is called, but I'm going to call it workshopping the script, because we need to make sure that each one of these steps works before we move on to the next step in writing the script to solve the level. Okay, so let's run the level 14 script. Combo Master says there's a new Jurassic Park movie. Yeah, that's correct. I think it came out, did it come out last year or 2 years ago? That's the one with Chris Pratt, right? Chris Pratt? Chris Pratt. Yeah. Alke Bulan, hello, nice to see you here on YouTube. Welcome, welcome. Okay, so yeah, well, we received a string. We received a really long string, and then we received a character, which is capital H. And then we converted those bytes into a string. So the first thing we received was bytes. In order to do most operations in Python, we need to work with strings. So we converted the bytes into a string over here. And the next thing we need to do is we need to isolate the two objects, because we're going to have one object, which is going to be this, and then there's going to be this object over here, which is going to be the character we need to count. So the next step is going to be this. So the next step is going to be, we need to convert the string into a list. Actually, I guess this is it right here. So convert the string into a list. I guess we'll call this string list. Yeah, that's going to be the same. This is the string converted to a list. And this is going to be the data. Data string dot split. AZ asks, is that Linux? Yeah, I'm using Linux right now. This is Kali Linux we're using right now. Shell and Tell says, no, there's a new Jurassic World coming out on July 7th. Wow, they made a new one, huh? I didn't know about that. Thank you very much. Thank you very much for letting us know, Shell and Tell. Okay, so this is, we're going to convert the string into a list using the split method over here. Let's see if it works. Okay, let's write that out, and let's run the script again. Okay, so this is the string converted to a list. So we got the really long string, and then we've got the character that we need to count over here. So the first element is the really long string, the second element is the character we need to count. AZ says, crazy, I've heard of Kali Linux. Did you find it hard to get used to? Kali Linux is just a version of Linux with a bunch of security tools installed. If you can use Linux, you can use Kali Linux. It's just the programs that are installed on Kali Linux are more cybersecurity and hacking type tools. But I mean, if you can get used to Linux, you can get used to Kali Linux. It's not difficult. Okay, so this is the string converted to a list. Great. Next thing we need to do is we need to separate the elements. So the next step is going to be separate the elements of the list. So we're gonna have two variables. We're going to have one variable called long string, and that's going to be string list element number 0. So the first thing in the list is the really long string, and the second thing in the list is the count character. So the character that's supposed to be counted. And that's going to be string list element number 1. So element number 1 is the second thing in the list, because in programming you start counting from 0. It's really fun. We're going to print out this message. So the message is going to be, this is the long string, and then we print out long string. And we're going to print out another message. This is the character we're supposed to count. And we will print out the count character. Okay, I need to resize my window a bit. Okay, so I think that's what we're going to check in this pass over here. Let's go ahead and run the script again. Okay, so this is the long string, and we've got the long string over here. That's great. And this is the character we're supposed to count, which is this. So those seem to match up. That's great. Let me change up my music, and then we will keep on going. Okay, so what are we doing? What are we going to do next? So I guess I need to figure out how to do a character count. This should be fairly easy inside of Python. I think there's a string method that does this. So Python count number of occurrences in a list. So count number of occurrences in the list. It's list.count method. List.count. And I'm pretty sure you can use count for strings as well. So we can just use the count method for the string. Okay, so let's see. So my lists element to count. Okay, let's see if we can create this. So the next step is going to be count the number of characters in the list. Cobblemaster says you could always use collection.counter. Collection.counter. Let's see if this works first. So we're going to make a variable called number of characters. So number of characters is going to be equal to longstring.count. Longstring.count count character. And we're going to print out a message. So this is the number of times that appears in the string. And we're going to print out here number of character, and we're going to print out count character. Let's see if this works. Okay, we're going to write that out, and we're going to run that one more time. Okay, so this is the character that we're supposed to count, which is lowercase t. This is the number of times that t appears in the string, which is 9. So this appears to be working, so that's good. The last thing we need to do is we need to convert this string, number of character, to bytes, and then send it back to the server. Okay, so we're just going to uncomment this. So bytes is going to be equal to number of character encode into bytes from UTF-8. And then we're going to print out, this is the string converted to bytes. We're going to send the challenge back by doing s.send bytes, and then we're going to receive the flag and complete the challenge. Or so we hope. Okay, let's write that out, and then let's run the script one more time. Oh, okay. We missed one step. So when the number of character right here, this is an integer, and we need to convert the integer to a string before we can convert it into bytes. So this is what we're going to do. So number of character, we're just going to change this to a string of long string dot count character. So this makes the object that is saved to number of character to we're going to make this a string. So that makes the rest of the script work, hopefully. Let's save that out. Let's run the script one more time. Great, it worked. Okay. So let's talk about what we did in the script. So we received a bunch of bytes, and then we received the bytes over here. So the bytes, the really long string, and the character that we need to count. We converted those bytes into a string in this section here. Then we converted the string into a list. In this section here, we isolated the really long string and the character we want to count. We turned the long string and the character we have to count into variables. So this is a really long string. This is a single character. And then we did our count. So this is the number of times that t appears in the string. So that was 11 times. Then we converted that string back into bytes, or we converted it to bytes rather, and then we sent that off to the server, and then we received the string. We received the flag, which is this. Okay, so the last thing we need to do to complete the challenge is to copy the flag and submit the flag to the server. Over here, let's go ahead and do that. That's the correct flag, great. Okay, so that was a guided walkthrough for level number 14 from the Temperance Labs over at HackMyVM.eu. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. So, Cobblemaster says that you could also use collection.counter. Collections.counter. So let me give that a try. So, okay. We got the script here. Let's see. Count the number of current characters in the list. This is the portion right here. Let me comment out everything else. And we'll try what Cobblemaster suggested over here. So collection.counter. So how do you use the collection.counter method? Python.counter method. So the .counter method in Python refers to the counter class found within the collections module. Oh, okay. So from collections import counter. So you'd need to counting elements in a list. Let's see, hello world, print character counts, counter, hello world. Ah, okay. So it counts out the number of times each thing appears in the list. I think, well, I mean, I'm pretty sure you could do it this way, but it seems like, it seems a little bit too complicated for this particular use case. But it's probably better for a different use case, but we could give it a try. So up at the top, we would have to import counter, and then we would run let's see, let's comment this out. We could run something like counter on string list 0, or sorry, counter on long string. And I guess we could print that out, and we'll see what comes out. Okay, let's see what comes out if we try that. Oh, okay. We need to spell it correctly. Okay, so we did get each element, each letter, and the number of times it appears. So it's definitely something we could use to count all of the characters that are included in a string or a list. I think, yeah, but it's a bit too complicated for what we're doing in this case. But thank you very much for pointing it out, Cobblemaster. Let's go ahead and I'm gonna record the solution that we wrote up here, and I'm gonna put it on the GitHub. So this is level 14. Okay, let me go ahead and grab that. And we'll save it in the GitHub as level 14. Create new file, level Ex1.py. Okay, save that out. Okay, awesome. Let's move on to the next level. Got a good amount of time left. Alright, so before we start, let me just reset my environment here. Alright everybody, we're doing level number 15 from the Temperance Labs over at HackMyVM.eu. Let's go ahead and talk about what we're doing in this level. So it says, in this mission you will receive a series of numbers. You must return what the next number in the series would be. So we've got some numbers over here, and we need to figure out what the pattern is for this series of numbers. And then we need to return what the predicted next number is going to be. I'm not very good at identifying patterns or mathematical patterns in numbers, so this is going to be a lot of fun, and by fun I mean not very fun. Okay, let's go ahead and start the challenge. We're going to be modifying the script we used for the previous challenge for this one. So we're just going to we're going to rename level 14 from the last level into level 15. And then we're going to edit it using the text editor. Okay, so everything up until here, we're going to make it the same, except that we're going to be selecting the level 15 instead of level 14. So we need to go down here, we need to select level 15. We're going to write it out, and then we're going to run the level 15 script. Oh, it looks like we still have... Okay. The reason why it didn't work was because we need to match up this comment out with something at the bottom that matches. So let me go back and do that. Okay, so it should be okay after this. Let's write that out again. Okay, so we receive a challenge. It's going to be these bytes right here. So these are numbers. 22, 60, 98, 136, 174. We need to find the pattern that matches these numbers, and then we need to send it back to the server, the predicted next number. So I think the pattern in the previous example over here, let me zoom in on this. So I think the pattern here is that these are all numbers that are separated by a consistent number. So we got 140 minus 59, and that's going to be one. Oh, I need to use a calculator. I'm very bad at math. Calculator. Okay, so the number is 149 is 59. So this is 81. So I suspect that all the numbers in the example here are separated by 81. So 140 minus 220, so 221 minus 140 should be 81 as well. 221 minus 140. 221. That's also 81. So this is the type of pattern we're going to be looking for in this challenge. So in this example here, it's 22 minus... The problem with this is that the challenge is going to be... The numbers are going to be different each time we do the challenge. Yeah, so these numbers are different, and that means that the algorithm for solving this is going to be different each time. But I'm guessing that the numbers are all going to be separated by... They're all going to be increments. They're all going to be the previous number with the number added on top of it, right? So in this case, it's 60 minus 22. I mean, that's a little easier for me. So it's 58, 38. So 38 plus... 60 plus 38 is 98, and 38, so 98 plus 38 is 136. So this kind of pattern. So I'm not too sure how we would do this in Python. So analyze a list of numbers, and then... Okay, let me do a little bit of research. So Python, analyze numbers to figure out pattern. So how do we do this? So analyzing numerical patterns in Python involves identifying underlying rules and relationships. Okay, sure. I think we might have to consult the AI to get an answer for this particular challenge. So let me try Claude AI. Claude AI is supposed to be good at coding stuff. So we can ask Claude. We have a series of numbers where each number in the series is the previous number with a constant number added to it. For example, so 22, and then we add like 12 to it, and then we get 34, and then we add 12 to this, and it's 46. We want to write Python code which identifies what the constant number is. Let's see if if the AI can figure this out. Okay, we got some code. Okay, so the code provides two approaches: full validation version, quick version. So we're always looking for the quick fix, right? Simply returns the difference between the first two numbers. Use this when you're confident that the sequence is arithmetic. Okay, so the difference between these two. Okay. So I guess in this case the pattern isn't very difficult to identify. It's just going to be the second number minus the first number. So the second number minus the first number is going to be the constant. So we just add the constant to the last number in the list, and then we should be good, right? Okay, so in this case, let's go back. So we got the pattern over here. What do we need to do? I think in this case we still need to convert the string into a list. The string, we're going to convert that into a list. And after we convert the string into a list, we need to separate the two numbers that are going to be compared. So separate the numbers that we're going to compare. So in this case, we need to the two numbers are going to be, we're just going to call this second number, and second number is going to be string list element 1, and the first number is going to be element 0, obviously. And why did I do second number and then first number? It's because we're going to be subtracting first number from second number. Okay, so we're going to print out a little message. This is the number we're going to subtract from, and that's going to be second number. Okay, and the other message is this is the number. This is the number we're going to subtract. And that's going to be the first number. And the last message we're going to print is going to be, so we're going to get the yeah, actually that's a bit premature. So that's the next step. So we're just going to separate the numbers that we're going to compare, and we're going to print those out. And then afterwards, we'll figure out what to do from there. Okay. So this is the number we're going to subtract from, 142, and this is the number we're going to subtract, which is 68. So 68, 142. So when we subtract the first number from the second number, that's going to be the constant. That's going to be part of the list of strings. Yeah. Okay. So the next step is to identify the constant number. Identify the constant number, and we're just going to create a constant number variable that's going to be an integer of second number minus an integer of first number. I'm going to print out this is if we subtract we get the constant number. Okay, and so if we subtract first number from second number, we get constant number, the constant number. Okay, let's see if this works. So write that out. Oh, we need to comment out everything. Okay, write that out again, and let's do it one more time. Okay, so this is the number we're going to subtract from 46. This is the number we're going to subtract 12. If we subtract 12 from 46, we get 32, the constant number. So we have the constant number. All we need to do is we need to add it to the last number in the list. So get the last number in the list. So last number, we're going to make this a integer because we need to do some math on it later. So last number is going to be the integer version of string list element minus 1. So element minus 1 is going to be the last thing in the list. And this is the last number in the list. Print out last number. And let's see. I think we can also do another thing in this step. So get the last number in the list. Do the math to figure out the next number in the pattern. So that's going to be predict number. So the predicted number is going to be the constant number plus last number. Okay, so we predict, oh, we're going to print that message. We predict that the next number will be predict number. Which is the constant number, plus the last number, Okay, let's see if this works. Okay, so if we subtract, this is the number we're going to subtract from, which is this. This is the number we're going to subtract, which is this. If we subtract 87 from 122, we get 35, which is the constant number. This is the last number in the list. We predict that the next number will be 262, which is the constant number, 35 plus the last number, 227. Okay, so I think if this is the actual pattern, then we should just be able to send this back after we do our conversion. Okay, so let's see, do the conversions from integer to string. Can we turn it to string, then string to bytes? Okay, so it's going to be we're going to call this the answer string. That's going to be the predict number, but type converted from integer to string. And then we need to convert this to bytes. So it's going to be bytes equals answer string dot encode from UTF-8. Okay, so we'll print out something like this is the byte version of the answer. The byte version of the answer is the printed bytes. Okay, let's see if this all goes okay. Oh, I wrote that incorrectly. Okay, so this is supposed to be an F string. Yeah. We predict that the next number will be 117. This is the byte version of the answer, which is 117. Okay, okay. So the last thing we need to do is we need to send these back, send the bytes back, and then receive the flag. Then we should be done. Okay. Great. What did we do in this challenge? So the first thing we did is we received a list of numbers. So we needed to convert this back into a string, and then we needed to convert the strings into a list. Then we needed to compare the pattern in the numbers by subtracting the first number from the second number. So we identified those two numbers, and then we got the constant number that is being used to create the pattern. So this is the constant added to this number, and then when we add the constant to this number, we get this number, etc., etc. We predicted the next number based on the constant number added to the last number in the list. Then we sent that answer back to the server as bytes, and then we received the flag, which is this. Awesome. Okay. Let's go back and submit that flag, and then we'll call this challenge done. Okay, we submitted the flag successfully. Great. All right, everybody, that was a guided walkthrough for level number 15 from the Temperance Labs over at HackMyVM.eu. If you enjoyed this guided walkthrough, please leave a like and a subscribe on the video, and leave a comment underneath the video. But until next time, HackerFrogs out! Okay, so let's go ahead and leave an ad on YouTube, because we're doing ads on Twitch. I'm just going to take a little water break for the next 30 seconds or so, but in the meantime, let's go ahead and watch some birds. How about these birds? Alright, we'll be back in about 30 seconds. Enjoy the birds and the music. You know, I was kind of worried that I was going to have to do some really complex mathematical coding with Python in that level, but it turns out that the pattern was very easy to identify, which is nice. I really don't like working with mathematical stuff. This is why I use computers to do my math for me. But let's go ahead and put the birds away, get back to the hacking. It looks like... oh! Looks like that was the last level we're doing for today. We're going to be moving on to the next part of the stream, because it's the top of the hour now. Alright, so let's take a look at what we're doing next. Alright, so let's see, it's Friday today. We're doing topic number 3. So for topic number 3, we're going to be doing something at HackTheBox. HackTheBox is a really great cybersecurity education platform, but I don't use it very often because a lot of the stuff, well, they don't have too much. They do have some free stuff that you can take a look at, but a lot of the stuff that interests me is paid, and I don't like doing paid stuff on the stream because I want everybody to be able to access the stuff that we do on the stream without having to pay for stuff. Because I understand that not everybody has a lot of money. I don't have a lot of money. But the stuff we're taking a look at today is, well, it's effectively free, so we can take a look at that together. Alright, so what are we going to be doing? So we're going to be doing the module on HackTheBox Academy that covers stack-based buffer overflows on Linux x86. So, oh, that's... I should probably get... Hold on. That's not the link you want to go to. We want to be looking at this page right here. Okay, so please use this link if you want to join along with us. So it says here that the this is a 7-hour module, but we're going to see how far we can get in the next hour or so. So it says here, buffer overflows are common vulnerabilities in software applications that can be X'd to achieve remote code execution or perform denial of service attacks. These vulnerabilities are caused by insecure coding, resulting in the attacker being able to overrun a program's buffer and overwrite adjacent memory. Okay, so let's take a look at what we're going to be learning inside the module. So the module is going to introduce buffer overflow attacks, principles such as CPU architecture and CPU registers. We're going to cover an introduction to buffer overflows, the basics of X development, okay, dealing with shellcode length and bad characters, public X modification, and buffer overflow protection. So we're just going to start. We're gonna start the module, and we're gonna see how far we can get within the next hour or so. Let's see. There's a button that lets us start the module, right? Okay, we got an overview over here. I guess we can click the start button as well. Okay, so buffer overflows are a type of software vulnerability, but they're not as common as they used to be. Let's see, these attacks are not limited to binaries. A large number of overflows occur in web applications. Okay. Especially embedded devices which utilize custom web servers. So buffer overflows are caused by incorrect program code, which cannot process large amounts of data correctly by the CPU and therefore manipulate the CPU's processing. Okay, so a particularly popular target on Unix systems is root access, which gives us all the permissions to access the system. However, as is often misunderstood, this does not mean that a buffer overflow that only leads to privileges of a standard user are harmless. Okay? Getting the coveted root access is often much easier if you already have user privileges. The most significant cause of buffer overflows is the use of programming languages that do not automatically monitoring limits of memory buffer or stack to prevent stack-based buffer overflow. These include the C and C++ languages, which emphasize performance and do not require monitoring. So one thing we are supposed to understand is that these kind of buffer overflow attacks can occur when the program was written using the C or C++ language. That's not to say that C and C++ are insecure languages, it's just that you have to be more careful when you're coding in those languages. Okay, let's go ahead and move on to the next section. So, X development introduction. So, let's see. Developing your own X can be very complex and requires a deep understanding of CPU operation and the software's functions that serve as your target. Many X's are written in different programming languages. One of the most popular programming languages for this is Python, because it's easy to understand and easy to write with. In this module, we will focus on basic techniques for X development as a fundamental understanding. Why did they put this in a different font? It must be developed before we can deal with the various security mechanisms of memory. Okay, before we run any X, we need to understand what an X is. An X is a code that causes the service to perform an operation we want by abusing the found vulnerability. Such code serves as a proof of concept in our reports. So there are two types of X's. There's going to be 0 days and there's going to be N days. So 0 days are newly identified vulnerabilities, and N days are known hacks, basically. Okay, so these X's can be divided into 4 different categories. There's local, there's remote, there's DOS, and there's web app. So local X's can be executed when opening a file. The prerequisite for this is that the local software contains a software vulnerability. So we can only use these kind of vulnerabilities if we have local access to the system. So we can't be accessing it remotely as opposed to this. So there's remote ones over here. So let's see. So they use a buffer overflow vulnerability to get a payload running on the system. This type of X differs from the local one because they can be executed over the network to perform the desired operation. Okay? There's DOS, which is denial of service. These are codes that prevent other systems from functioning, for example, by causing a crash or crashing the entire system. And there's also web app ones. So these are going to use a vulnerability in web application software. So the vulnerabilities can, for example, allow a command execution on the application itself. Okay, so we're just going to mark this, move on to the next section. So the architecture of von Neumann was developed by the Hungarian mathematician John von Neumann, and it consists of 4 functional units. There's memory, the control unit, the arithmetical logic unit, and the input-output unit. Okay, so I don't know very much about CPU architecture, but it seems like as good a time as any to start learning about it. So in the von Neumann architecture, the most important units, the arithmetical logic unit, ALU, and the control unit, are combined in the central processing unit. So the ALU and the CU are in the CPU. Okay? The CPU is responsible for executing the instructions and for flow control. The instructions are executed one after another, step by step. Commands and data are fetched from the memory by the CU, the control unit. The connection between processor memory and input-output is called the bus system. Okay, which is not mentioned in the original von Neumann architecture, but plays an essential role in practice. So in the von Neumann architecture, all instructions and data are transferred via the bus system. Okay, so we've got the CPU on this side, and then we've got the input and output devices on the opposite side of the bus. And then we got memory on the other side of the bus as well. So basically, all the instructions that are being issued by the CPU have to cross the bus to access the memory and the input-output devices, and everything is going to cross from those devices across the bus to get to the CPU. Okay? Great. So memory can be divided into two different categories. There's primary memory and secondary memory. Okay. So the primary memory is the cache and the random access memory. If we think about it logically, memory is nothing more than a place to store information. Okay, so memory is a place to store information. So the cache and random access memory. So random access memory describes a memory type whose memory allocations can be accessed directly and randomly by their memory addresses. The cache is integrated into the processor and serves as a buffer, which is the best case, ensures that the processor is always fed with data and program code. Before the program code and data enter the processor for processing, the RAM serves as data storage. The size of the RAM determines the amount of data that can be stored for the processor. However, when the primary memory loses power, all stored contents are lost. Okay. So this is secondary memory. The next thing we're talking about is, it's basically storage devices. So secondary memory is external data storage such as HDD, SSD, flash drives, and CD, DVD-ROM drives of the computer. They're not directly accessed by the CPU, but via I/O interfaces. Okay, so this is secondary memory. Control unit. Control unit is responsible for correct interworking of the processor's individual parts. So what is a control unit? So the control unit does this. Reading data from the RAM, saving data in the RAM, providing, decoding, and executing instruction, processing inputs from peripheral devices, processing outputs to peripheral devices, interrupt control, monitoring of the entire system. So the control unit contains the instruction register, which contains all the instructions that the processor decodes and executes accordingly. Okay. And then we've got the central processing unit, which is the CPU. It's a functional unit in the computer that provides the actual processing power. It's responsible for processing information and controlling the processing operations. To do this, the CPU fetches commands from the memory one after the other and initiates data processing. The processor is also referred to as a microprocessor when placed into a single electronic circuit as in our PCs. So each CPU has an architecture on which it is built. So the best known CPU architectures are x86 and i386, which is made by AMD and Intel, x86-64 and AMD-64, which is made by Microsoft and Sun Microsystems, I think that's what it's called, and ARM, which is made by Acorn. That's what I'm guessing. So each one of these CPU architectures is built in a specific way called instruction set architecture, which the CPU uses to execute its processes. Instruction set architecture. So ISA therefore describes the behavior of a CPU concerning the instruction set used. The instruction set used are defined so that they are independent of a specific implementation. Above all, ISA gives us the possibility to understand the unified behavior of machine code in assembly language concerning registers, datas, and types. So there are 4 different types of ISA, or instruction set architecture. There's CISC, RISC, VLIW, and EPIC. Instruction set architecture. So this is all kind of new to me. Like I said, I don't know very much about CPU architecture, but there's going to be a lot to learn over here. I think this is important to know, if you're getting to these are a lot of words. I thought it would be a lot more hands-on. I thought this the stuff in this module would be a lot more hands-on, but I guess they have to do their they have to cover all their bases when they're talking about this stuff. So, I think I might ask the AI to give me a summary of this. Okay, so what are the practical differences between these, what are they called? Because, I mean, the stuff here is kind of dry. Instruction set architectures. Sigma says, reminds me of the OSI model, so much theory. I mean, the OSI model was a little bit more exciting than this, but this is what the AI is good at. It can take some material and it can break it down into simpler ways of thinking. Okay, so there's these 4 things, right? So CISC is complex multi-cycle instructions. Hardware handles instruction decoding and microoperations. Variable length instructions. Okay, so pros, smaller code size. Legacy support. So x86 is CISC based. So complex instruction set computing. So I mean, this is what we're talking about when we're doing our x86 buffer overflows. So it's less to do with some of these other instruction sets. So the use cases are for general purpose computing, so Intel and AMD x86, legacy systems where code density matters. So the reduced instruction set computing, this is something that we see in mobile devices, I'm pretty sure. So simple fixed length instructions, load stores architecture, hardwired code, so easier pipelining, better for superscalar and out of order execution, more power efficient. So I'm pretty sure we're talking about mobile devices here. So larger code size, compiler must optimize for instructions. So use cases for this are mobile or embedded, so ARM and RSCV. So high performance computing such as Apple computers. So in some supercomputers, we've got very long instruction word. What is this stuff? Bundles multiple independent operations into one long instruction. Compilers, okay, pros. Simple hardware. Simple hardware. Instruction level parallelism. So what do we use with this very long instruction words? So DSPs, digital signal processors. Niche embedded workloads with predictable execution. Okay, so explicitly parallel instruction computing. Compiler. So, I mean, that's a lot of words. Yeah, Sigma, you're absolutely correct. But I think when we're talking about most of the stuff that we deal with in our day-to-day, I think we're dealing with this one over here, CISC and RSC. So this is basically desktop computers and stuff that works with x86, and this is stuff that works with mobile devices and with Apple devices. Okay, let's so CISC versus RSC. So this CISC favors legacy and compatibility, and RSC favors efficiency and scalability. So modern x86 blends both of these. All right, let's move on. Okay, it says nevertheless, pretty much all CPUs have a portion of RSC in them. RSC architectures have a fixed length of instructions defined as 32-bit and 64-bit. We find RSC in most smartphones today, for example. Okay, and we've got this. So, complex instruction set computer, processor architecture with an extensive and complex instruction set. The addressing in CISC architecture does not require 32-bit and 64-bit in contrast to RSC IC, but can be done with an 8-bit mode. I suppose we'll figure out more as we go, and if we get stuck, we'll go back and talk more about this. Okay, so this is what we came here to talk about. We came here to talk about stack-based buffer overflow. Okay, so binary files are a general executable files stored on a data storage medium. There are several different file formats for such executable binary files. For example, portable executable format used on Microsoft platforms. So the main difference between the executables on your Linux device and on your Windows device is that the Linux device is going to use this one over here, the ELF format, executable and linking format. And the ones that are used on Microsoft, those are going to be these ones over here, the portable execution format. Okay, so to understand how it works on a technical level, we will need to become familiar with how the memory is divided and used, how the debugger displays and names the individual instructions, how the debugger is used to detect such vulnerabilities, and how we can manipulate the memory. Okay, so this is my favorite part. My favorite part is talking about how memory is organized inside of programs. So when a program is called, the sections are mapped to segments in the process, and the segments are loaded into memory as described by the ELF file. So we've got our memory buffers. Okay, so we got the different sections of the program, and then we've got the stack. So the text section, the data section, the BSS section, the heap. There's a bunch of empty space in the middle, and then there's a stack at the very end. So at the very beginning of the memory address, we've got the actual instructions for the program, and then the stack begins at the very end of the memory address, and then it grows outwards towards the beginning of the memory address. Okay. So what are these different sections? So the text section contains the actual assembly instructions of the program. The area can be read-only to prevent the processes from accidentally modifying its instructions. Any attempt to write to this area will inevitably result in a segmentation fault. So the program instructions are the .text section, which doesn't make sense because there's these are assembly instructions and not text. Okay, so the .data section is going to be global and static variables that are explicitly initialized by the program. So if you've got any variables that are what is the word? That are defined by the program, they're going to be in the .data section. So the .bss section, several compilers and linkers use the BSS section as part of the data segment. which contains statically allocated variables represented exclusively by 0 bits. So these are uninitiated. So these are variables without values. So they're variables that are going to become defined during program execution, and this is the section where they're kept. We also have the heap, and this is heap memory. So heap memory is allocated, and the area starts from the end of the BSS segment and grows towards higher memory addresses. So the heap is over here, so the beginning of the memory is over here. After the other 3 sections, there's the heap, and that grows towards the higher memory addresses. And the other part of the memory, which is the memory stack, starts at the end of the memory address and grows towards the lower memory addresses. So stack memory. So this is mostly what we're talking about when we're talking about stack-based buffer overflows. And stack memory is a last-in, first-out data structure in which the return addresses, parameters, and depending on the compiler options, frame pointers are stored. So C and C++ local variables are stored here, and you can even copy code to the stack. The stack is a defined area in RAM. So one thing that we need to note is that the reason why we don't have very many stack buffer overflow vulnerabilities in modern programs is because of modern memory protections. So modern memory protections like DEP and ASLR, they prevent the damage caused by buffer overflows. So there's data execution prevention. Platino, hello, nice to see you here. How is this related to hacking in Python? Have I just arrived? Platino, hello, nice to see you here. We did our hacking in Python stuff in the 2nd hour of today's stream. So if you go back in the YouTube video to about 50 minutes after the start of the stream, that's when we start our hacking in Python section. But yeah, we finished the hacking in Python section already. Okay, so let's see, we got DEP, which is data execution prevention. So marked regions of the memory read only. So that means that if for some reason there's a stack buffer overflow, the regions that are labeled as data execution prevention are not going to execute any data. So the idea behind DEP was to prevent users from uploading shellcode to memory and then setting the instruction pointer to the shellcode. So hackers started using ROP, return-oriented programming, to get around this, as it allowed them to upload the shellcode to an executable space and then use existing calls to execute it. With ROP, return-oriented programming, the attacker needs to know the memory addresses where things are stored. So the defense against it was to implement ASLR. And ASLR is address space layout randomization, which randomizes whatever is loaded, it randomizes where everything is stored, making return-oriented programming more difficult. Users can get around ASLR by leaking memory addresses, but this makes X's less reliable and sometimes impossible. Okay, we've got an ad running on Twitch, so we'll run one on YouTube. And we'll put on some birds. How about this bird? Okay, enjoy the birds, and we'll be back in about 50 seconds. Okay, let's put the birds away. Let's get back to the hacking. So let's talk a little bit more about this. So let's see, we've got a vulnerable program over here, and we're now writing a simple C program called bow.c with a vulnerable function called string copy. So string copy is one of those notoriously insecure functions inside of C code. And what are we doing over here? So we're going to create a function called the bow function. So we define a buffer as 1024 bytes, and then we string copy into the buffer the string. So where do we define the string? Oh, okay. So the string is basically whatever we give to the bow function as this argument over here. Okay. So modern operating systems have built-in protections against such vulnerabilities like ASLR. For the purpose of learning the basics of buffer overflow X's, we're going to disable the memory protection features. Okay, so can we do this? Can we do this in our own machine? Okay. You know, I think we might be able to do this in JS Linux. So JS Linux is a JavaScript implementation of Linux, which we can access from any web interface, and this is the one I use over here. So we might be able to use JS Linux to do the examples in the HackTheBox module over here. Okay, so let's see. Let's turn off the memory protections by giving these commands. Okay, let's go ahead and do that. And then let's go ahead and read and see if we manage to turn off the memory protections. You know what? Another thing we need to consider is whether or not these protections are in place in the first place. You know what? I'm gonna check to see if these memory protections are in place on this Linux box. Because well, I mean, you know, these versions of Linux might not all be the same. Okay, so it's a 1 or 0 setting. So we're just going to echo 0. Okay, so that turns off the ASLR, I guess. Disable ASLR. Okay, so this is all we need to do over here. Okay, next we compile the C code into an ELF binary. So I think GCC is installed on the JS Linux. So let me check. So which GCC? Yeah, so we have GCC here. Let's go ahead and grab the code then. So we got the code here. I'm just going to copy all of it. And I think we're going to call this file bow.c. Cobblemaster says, you need system root to disable ASLR, right? I mean, I think the file is probably owned by root. Let me check. Yeah, so the file is owned by root, so you're going to need root access to modify this. Let's create the bow.c file. Okay, and then we're going to paste this stuff in. Oh, that looks kind of ugly. I don't think, yeah, the formatting's all wrong. Hold on. Yeah, I need to change this up. Okay, so okay, so what does Well, I mean, I'm not sure. I think this will compile okay. I mean, if it doesn't compile okay, I'll find out pretty soon. All right. Let's go ahead and go back. So how do we do this? Okay, now we can compile the code into a 32-bit ELF binary, and I guess this is the command we would do it with. So I'm just going to go ahead and give this command inside of JS Linux. Unrecognized command line option M32. Well, I mean, it didn't compile it. Okay. Hold on. M32. That didn't work. Can I... Let's try asking the AI if it can give us a quick fix. Okay, I'm having a problem with my GCC compiler. Okay, so the GCC installation doesn't have 32-bit compilation support. Here are the solutions. Install the well, I can't install the libraries. Okay. Check if you have a separate 32-bit GCC. So look for GCC multilib. So which GCC? Let's check. Actually, you know what? I think JS Linux might have a 32-bit virtual machine as well, but I need to check. Okay, so I'm assuming that these all are going to be 64-bit systems, but that's okay. They said you need to install multilib. So we can compile it without the 32M flag. Use a 32-bit container VM. I mean, the other alternative is to do it on my Kali Linux system. And I guess we could do it on the Kali Linux system, but then I need to make sure to turn back on the protections afterwards, because otherwise that would be a really big no-no. Where else could I do this? I just need some Linux box. Not necessarily my Linux box. I'm considering whether or not, no, well, you know what, I don't, I could try doing this as, I could try doing this without 32-bit, but I'm not too sure what this would look like if I compile this as a 64-bit binary. Okay, so that creates a binary called BOW. Okay, sure. But this is a 64-bit executable. I mean, we'll figure out if this is a big problem or not in just a sec. Okay, so vulnerable C functions. There are several vulnerable C functions that don't protect memory. So the famous ones are things like string copy, gets, sprintf, scanf, string cat, concatenate, and then they introduced us to the GNU debugger, so GDB. So this is the standard debugger of Linux systems. Okay, we can use the GDB to view the created binary on the assembler level. Yeah, you know, Pebble, I was really surprised that you were doing this exact module in your stream, because it was something that I scheduled for my stream as well. But welcome to the stream, Pebble. Did you learn a lot of cool stuff during your examination of this module? I'm sure you did. Okay, so we'll use GDB to view the binary on the assembly level. Okay, so GDB Q -Q. Okay, so here we are. GDB -Q. Yeah, I mean, the thing about the stuff over at HackTheBox is that it's very in-depth. Sometimes a little too in-depth, but hopefully it wasn't too boring. So GNU debugger, it seems to be taking a while, huh? Come on. Oh, you know what? Pebble, let me ask you, did you know debugging symbols found in BOW? Huh. Oh, okay. I mean, I guess that's okay. Let's take a look. All right. So, yeah. So new debugging symbols found. Disassemble main. So this is the instruction. So this gets all the instructions that are in the main function over here. You know, strangely, I don't... Okay, so these are... You're missing the -G flag. The -G flag, where was that indicated? Dump of these. Okay, so I recognize these ones, these instructions here, but I don't recognize these instructions. Oh, it's because they're 64-bit. Okay. Yeah, I mean, I couldn't do 32-bit on on this system right here, which is the web accessible system that I decided to use. I think it's also because the oh, you know what? Hold on. The reason why it's not working is because this is RISC-V architecture. I should really compile it on the Alpine Linux over here, which is x86, because we're dealing with x86 architecture. So I guess I made a mistake. Yeah, this isn't the right CPU. But it's good that I identified that. Otherwise, I would have had a very bad time. Okay, let's do this again. Just gotta wait for this to boot up. Wait, is this not a console? This is a... okay, I don't want a graphic user interface. I just want console. Yeah, I clicked on the wrong link. Give me CLI, please. Okay, awesome. Okay, so this is the right architecture, hopefully. First I need to disable DSLR. Where is that instruction? Here? Okay, so let's take a look. So this is 1, we want to make it 0. We are root, right? Yeah, we're root. Okay, and are we using bash? Echo shell? No? Anyways, let's try compiling that binary one more time. Okay, so the binary is, well, the code is over here. Okay, so nano yeah, this okay, let's see if this works. Let's compile the thing. What was that command? So the command they want us to use to compile it is this. Okay, that worked. So we were actually able to create the 32-bit version of the binary using this other version of JS Linux, which is pretty cool. Oops, that isn't going to work. This will. Okay, so this is the exact type of file that we want to look at. So let's run gdb with -q on bow32. And then we're supposed to do disassemble main afterwards. So just for everybody's reference, I don't have too much experience with the GNU debugger, but I probably should become more familiar with it because it's pretty much standard on every Linux device. Okay, so disassemble main. Okay, so these are instructions that I am familiar with. The reason why I couldn't read the other instructions was because they were made for the RISC-V CPU type. Okay, so what are we supposed to understand about this HackTheBox? Okay, so in the first column, the hexadecimal numbers represent memory addresses. So these are all memory addresses over here. And this offset is basically the offset from the lowest memory address. Actually, no, it's not. It's the offset from the first instruction. Okay. So this is the memory address right here. This is the offset. This is the instruction. And this is the... Actually, this all combined together is the instruction. Okay, cool. First column, there's hexadecimal addresses, memory addresses, okay? The numbers with the plus sign shows the addresses jumps in memory in bytes used for respective instruction. So we can see assembler instructions, mnemonics, with registers and their operation suffixes. The current syntax is AT&T, which we can recognize by the % and $sign characters. Okay, so this is the load effective address instruction, and I'm not too sure what this one is. What is the AND assembler instruction? Let me look that up real quick. x86 assembly and instruction. It's just AND. Wait, when you say just AND, hold on. Okay, let's change up the music and then we will continue. It's a bit, oh, okay, so it's an AND bitwise instruction. Okay, cool. So the Intel syntax makes disassembled representation easier to read, so we can change the syntax by entering the following commands in GDB. So set disassembly flavor Intel. This is actually what I'm more used to looking at. So this is Intel versus AT&T. Okay, let's do that. Let's make this smaller. We can't clear our screen. Can I? Hold on. Let me try resizing the window a bit. You know, I'm kind of disappointed that I can't clear the screen. Nope. Okay, let's just put on that instruction. Let's see. Disassemble main. Okay, here we go. Just press enter 10 times. Well, I mean, we could. We could. Okay, so we've got our Intel instructions. These are much easier to read. These are much easier to look at. Okay, so load effective address, all this good stuff. Okay. So we don't have to change the display mode manually continually. We can also set this as default syntax with the following command. Okay, so we can just change a configuration file to do the same thing. Alright, great. The difference between AT&T and Intel syntax is not only in the presentation of the instructions with their symbol, but also in the order and direction in which the instructions are executed in red. With the Intel syntax, we have the following order for the instructions for the example. Okay. Ah, okay. So this is interesting because some people actually prefer that you put the destination second and you put the source first in the instructions. Cobblemaster says basic. The stack pointer jumps to the code. The stack pointer jumps to the code line. So the stack. But I mean, I've been kind of conditioned to follow this order right here. So the destination is going to be first, and then the source is going to be second in these assembly instructions. So what do they want us to do? Connect to the pwn box. I don't think I will. Okay, so the questions after... Answer the questions below to complete the section and earn cubes. At what address in the main function is the bow function called? At which address in the main function? I can Well, I mean, I can just answer that from the JS Linux. So the bow function is called here at this memory address. Let me just copy that. That wasn't hard. Okay, paste that in, submit that. Incorrect answer. Is it incorrect because it was compiled on a different machine? And Wireshark says, great stuff, bro. Hello, nice to see you here. And Aqua says, hey, nice to see you, Aqua. Welcome to the stream. Okay, so let's see. At which address? Is there something wrong? Gotta put SSH in. SSH in with the user student. I mean, I'm just trying to answer the question. At which address is the main function? Oh no, the main function, not the bow function. Okay, let me get that answer one more time. Okay, so call main. Oh, okay. So I think it's this first one right here. It should be the first address. Okay, let's see if that's the answer. That's still not the correct answer. There was another program we could use to disassemble. We could use to disassemble the program, right? Let's see. Okay, let's try asking Claude. So in standard Linux file systems, which tool can we use to disassemble a binary? So there are a few different programs that we can use. So yeah, we can do object dump D. Object dump D. Okay, let's get out of here. Quit. Okay, so object dump D, bow 32. Different addresses per OS. It could be, I mean, it could be that. It could be that, yeah. I mean, that wouldn't be very fun. Let's see if I can squeak something out. So where is it? Where is main? Main. Okay, so it says that this is the address of main. Let's see if this counts. Well, I mean, I'm pretty sure that's the same one. Oh, jeez. Okay, we'll try submitting this. If this doesn't work, we can try 0x. Yeah, still not the same. But I guess I could just log into the system. So click here to spawn the target system. I don't know if I've got the VPN key. So I've got my VPN key, sure. Let's start up the system. Let's do the thing. Let's see, how do we start? Click here to spawn the system. Diz says, I just watched a video on reverse engineering and he said to download the IDE. I mean, we don't necessarily need to download an IDE. OreoByte says, do you need more time? In assembly, the entry point is start, not in main. I mean, they're asking for the address of the main function. Which address in the main function is the... Oh, no, they're looking for the bow function. Okay, hold on. I might be able to answer this still. So the bow function is this. Let me check the thing. Here's the bow function. So if I can answer this without having to start up but OreoByte, give me 5 or 10 minutes. I just want to get this answer done before we start our collaboration. Okay, so I mean, if I want to connect to the machine, I need to go over to it in my terminal. VPN connection, jeez, okay. It's called, is it called Academy something? Dyslexia. Let's see. OreoByte says I'll be back at 6:10. Okay, no worries. Thank you very much, OreoByte. Yeah, so let's see. We'll start up that connection. Let's see if we can SSH in. So SSH. What are the credentials? Wait, did I probably didn't answer the thing correctly. Okay, so we got our HTTP student, and then what's the IP address? It's this one. Okay, so I mean, at least we can connect to this pretty easily. That's nice. This is our password. Okay, done. All right, so we got the bow program here. So let's go ahead and do GDB. We can also do object dump as well. It's probably easier. Okay, so we're looking for the bow function in here. So bow function is at this address. Yeah, hold on. Let's reload the page. I just want to get this answer done. Okay, so where were we? Yeah, here we are. Couldn't I use grep? Well, we could use grep. If we were smarter people, we'd probably use grep. Okay, let's submit that. Incorrect answer. At which address in the main function is the bow function called? Are they looking for... What are they looking for? Because we got the address right here. You have to look for where the function is called. Where the function is called. Okay. So I guess we do need to use GDB then. So GDB -d bow. Okay. Bow is not a directory. Hold on. Let's quit out of here first. So GDB -d bow. Bow is not a... Why does it still say this? Okay, so we do disassemble main. No table is loaded. I think I've got my syntax incorrect. I need to double check. So how do we run that GDB again? GDB Oh, dash, okay, so GDB and then the file name and then dash Q. So GDB, then the file name, and then dash Q. Okay, that works. And then we do disassemble main. This is the dump for main. And then we're looking for the bow function. So it calls the bow function at this address. So that's probably the answer. Please be the answer. Submit that. Yay, that was the answer. Okay, complete and next. Awesome. So Pebble, are you Pebble, if you're sticking around, me and OreoBite are going to be doing some tag team hacking stuff in just a little bit. So we're going to be wrapping up in just a second. So our good friend OreoBite is going to be joining us on the call on Twitch, and we're going to be doing some hacking against the echoCTF platform here. And we've got a network of machines that we need to hack against. And if you're interested in taking a look at this yourself, you can go over to this link. echoCTF is free, and you don't need to pay to get access to it, and there's a lot of machines that you can hack against. It's very nice. But I'm going to get ready for the collaboration. It's going to be starting in just a bit. Pebble would run through that stuff. Yeah, I don't doubt it. E-Dog, hello, E-Dog, nice to see you here. And you know what? I mean, you're free to give this a shot if you want to. But let me start up my connection over here. OpenVPN. Let's see. So echoCTF one, okay. And well, I mean, the great thing and the not great thing about these machines is that it's shared access. Pebble says, about to go to bed on the East Coast. Oh wow, it's like, all right, that's cool, that's fine. Yeah, so I mean, I hope we don't look like complete dummies. gotta perform for our good friend Pebble over here. Okay, so me and OreoBite, we did these first 3 boxes the last time we were here, and we're going to be doing these next boxes. We'll see how far we can get. There's the next box here over here called Dasher. We'll see how we'll see how easy the challenge is. The previous challenges haven't been too difficult, but we'll see what happens. Okay, just gotta wait for OreoBite for a bit. In the meantime, I guess we could take a look at some of the other stuff from the HackTheBox room. Okay, so we're talking about CPU registers over here, and CPU registers are basically places where the CPU can put data for execution. So these registers over here, they're pretty commonly used whenever we take a look at buffer overflow stuff. So there's EAX, EBX, ECX, EDX. So basically, you don't need to pay attention to the E and the X. At the simplest form, each one of these memory registers are basically just the A register, the B register, the C register, and the D register. So if you strip away all of the other parts of the register name, then this is just the A, B, C, and D register. So this is the accumulator, the base register, the counter register, the data register. But they take on different names depending on if you're dealing with 64-bit CPU architecture or 32-bit CPU architecture. And we've got our pointers as well. So there's the I pointer, the S pointer, and the B pointer. So the I pointer is the instruction pointer, the S pointer is the stack pointer, and the B pointer is the base pointer. let's see. Vo. I'll call you Vo. I'm not too sure. I'm pretty sure that's a Vietnamese name. I don't know how to speak Vietnamese. I'm not gonna try to pronounce the name because I don't think I can do it. But Vo, hello, nice to see you here, and good morning to you. You must be in Vietnam if you're saying good morning right now. Phantom says hello. Hello, Phantom, nice to see you here. And you know what? For everybody who hasn't been around for a bit, we like to do our fun video redeems over here. How about we do a good old Hack the Planet?
Hack the planet! Hack the planet! Shut up again!
Okay, so the basic goal of stack buffer overflows is to control the stack pointer. And Vo, hello, nice to see you here. Thank you very much for subscribing on YouTube. Thank you very much. It's going to be to control the IP pointer. So I mean, I guess no, yeah. Hold on. So it's IP, SP, and BP. So these are the pointers. So user on YouTube says buffer overflow vulnerabilities common in systems, meaning that there are a lot of them. They're difficult to detect. I mean, even if there are these kind of vulnerabilities in the systems, the problem is that there's I wouldn't say this problem. The thing is that there's a lot of memory protections these days that prevent people from taking advantage of stack buffer overflows. Phantom says there's a CTF currently going on, hosted by TryHackMe. Industrial intrusion. I don't know very much about industrial stuff, but you know what? If you're interested in the CTF competition, I might as well give a little bit of publicity to TryHackMe. So this one over here. Wow, they're offering a lot of money and prizes. So this is a team room. Only team achievements are displayed on the scoreboard. Okay. So, I mean, it seems to be a pretty popular thing, yeah? I'll leave the link for the room in the chat, just in case you want to take a look at what's going on. Let's see. So what is the most serious vulnerabilities in systems? What is the most serious vulnerability in systems? It depends on which system you're talking about. Are you talking about, like, the operating system, or are you talking about web applications, or are you talking about something else? Because they're all kind of different things. Oreobyte asks, what is the plan? Well, the plan is to... Okay, let me accept your collab invitation first. Let's talk about Windows. So, that's an interesting thing. Oreobyte, hello.
Hello.
Hey, I think, could you...
You think what?
Okay. So I'm answering a question from somebody on YouTube right now. They're asking about what is the most serious vulnerability in systems. It seems kind of vague. So they say, in general, the systems, given their complexity, are there many loopholes in them, or is it impossible to finish them? Well, if you're talking about Windows, what are the most serious vulnerabilities in Windows? I mean, I guess most
that depends on what is the attack chain.
I mean, I
feel like the most... When I think of the things that scare me the most are the phone zero-click exploits, where you don't have to do anything, you just get pwned immediately.
I mean, I think this user's asking about like Windows stuff, and I guess I mean, it's not just for Windows stuff, but I think the most serious vulnerability is security misconfigurations. It's just somebody not configuring their system correctly and leaving like security problems.
Yeah, the two things are either new vulnerabilities or misconfigurations. Because if it's known, then it's labeled as the misconfiguration. Like, you don't update your system because you're afraid of breaking. Like, oh, reported but won't fix.
Well, I mean, I would figure that like legacy compatibility causes a lot of issues inside of Windows, like something that's specific to Windows.
I feel like... Was there a question originally for Windows?
Well, I think the question originally was for systems. But if you're just talking about systems in general, I think that it's more about
Individual
security.
systems, Active Directory systems, systems that you have physical access to that you can just...
I think they're
into
just talking about
Linux
all.
and-
If you're just talking about all systems, I would just say that it's security misconfigurations. People aren't configuring their stuff properly, and it's leaving it vulnerable. That's my take.
Because physical access is root access.
Right. If you if you have physical access to a device, then it's your device. Okay. So are you connected to the echoCTF network?
Yeah, I've already started the machine.
You started the machine. Okay. So if I restart,
Dasher, right? We're doing Dasher for continuing where we left off.
we're just I see the IP address here, and we're gonna start the machine. Phantom asks, do you know about Modbus TCP registers? Modbus TCP registers. This feels like more CPU architecture questions. Is that something you know about, OreoBite?
Not at the moment.
Yeah, I'm not sure about Modbus TCP registers myself. Okay, so let's start our Nmap scans. So do you run your Nmap scans as sudo?
The only Nmap scan I run as sudo is the UDP scan. I usually use Rust scan initially.
Oh, you use Rust scan. Okay.
So I find all the ports, and then I do a script scan with Nmap for speed.
Yeah, I haven't tried Rust scan, but I hear that Nmap runs better if you run it as sudo. So I've decided to start running it as sudo. I don't know why it would or would not run faster with sudo, but I'll give it a try. I don't find any. I'm not finding any ports so far.
I found 80, 85.
80, 85. Okay, that might take me a little while to get. And I'm guessing 80, 85 is some sort of web-based port. So maybe I can just go over there. 80, 85. Okay, it's some sort of dashboard. It looks like Git something. GitHub. There's a link to a GitHub repository. Do you see it? Shivam says hello. Nice to see you, Shivam. Welcome on YouTube. Welcome to the stream. Phantom says, RustScan is great for Nmap. There are some flags which require sudo privileges. Well, I mean, most of the time when you're running... I guess if you're running Nmap but you don't have sudo privileges on the machine, that could be a problem. But, I don't know. Shared chat has started, thank you. Okay, so...
The one time Al-Hazred tried RustScan, he couldn't find a port because it ran too fast.
Oh, yeah?
And then, of course, every time that he's recommended a tool that doesn't work for him, he stops using it.
Okay.
But I like it.
Well, I mean, the same thing can happen in Nmap, really, right?
If you use the options to run faster, yeah.
Yeah, well, I mean...
That is it. Okay. Is that the only port?
Yeah, I mean, if that's the only port, there's some sort of dashboard here. I'm not too sure what this application is doing, but there's a GitHub repository that is linked at the top. So Dasher is a minimal and lightweight dashboard for your self-hosted services and bookmarks. So the first thing that comes to my mind is that we should look for known hacks for Dasher. What do you think?
Can we get a version?
Well...
Or does the map tell you?
I mean, I haven't gotten a version. But let's just see if there's something available for the application in general. So if we look for known X's, we don't find anything. Okay, well, so search doesn't work. How about we just look for...
Oh, this is from, when I was streaming, and then nobody said anything when I forgot to unmute my microphone. Oops.
Well, I mean, I wasn't there, so you can't blame me. Okay, so I found an article that says that Dasher could allow a remote attacker to upload arbitrary files. But let me link you the article. Oh. First of all, let me click into the article. Okay, that's the link. And... okay, so it could allow remote attacker to upload arbitrary files caused by improper validation of file extensions by the filesave.php script.
Okay. So, did you check the view source?
Pardon me?
There's a GitHub page in the view source. I mean, they're also in the page. I didn't have to do view source for that.
Did you find a version?
I didn't find the version, but I found the original project, which wasn't hard to find. I thought I was being smooth by looking at the view source, but it's actually just a button on the page, or a redirection on the page.
Most of these links don't go anywhere. Have you taken a look at the links on the page?
If you look at the top right, the GitHub.
Yeah, I see the GitHub page. I mean, I was taking a look at it. But most of the links on the rest of the dashboard here don't go anywhere. Oh,
So that's it. That's all the issues. Could settings to JSON file.
okay. What else do we have here? Huh. What is... So... I'm looking at the self-hosting page that's located at the bottom.
That's the only thing that has a parameter.
Well, I mean, I mean, there's a parameter here, but is it getting... Where's it getting these files from? So if we give it an LFI payload, is it going to give us anything? Okay, it doesn't seem to get us anything. Well, I mean, I don't see any place where we can authenticate in this application, do you?
Not yet.
I mean, I guess we should.
I haven't scanned. I'm just testing. I probably just run that in the background real quick.
Hold on. Well, I mean, if we have access to the GitHub repo, we could probably just take a look at how the application is structured, right?
Filtering through the issues page, it doesn't seem like there's any like major bug.
Mm-hmm.
That was reported.
So, we should probably look and see where the configuration files and stuff are kept. Okay, so if we go over to www. So this is index.php, there's an editor.php. So the main page we're looking at is... it's probably index.php. Yeah, so this is index.php, so that means there's an editor.php. Okay, cool. Let's see. Shivam Kumar says, no fluff, only hacking, great. we try to keep the fluff to a minimum. Streamlabs, thank you very much for following Haveinto. I'm not too sure how to pronounce that. But thank you very much for following. And Siva, hello. Hello, Siva. Nice to see you here. And welcome to the stream. Let's give you all a fun Nyan Cat.
Can we actually save that PHP instead of file?
Could you repeat that?
Not found. It says includes.
So can we? So there's an editor.php page. Can we save PHP code to the editor here? So try going to the editor.php endpoint.
Is it under includes or is it somewhere else?
No, it's just in the web root. In the web root, go to editor.php.
Okay, I found it with the. Put this here.
Okay, so let me try.
This looks like JSON.
Okay. I mean, my question is whether or not we can execute PHP code from here. Although I guess, I don't know.
The file is that misspelled?
Setting sample JSON. There's
the
also
file save PHP exists.
So there's a save button, right?
Yeah, we can save the file.
Yeah. Okay, so there's also the include directory. I wonder if the include directory is listable or not. Probably isn't. Yeah, so we get 403 forbidden, but they're the individual files that we can take a look at in there as well. Like custom.css.
Unrestricted file upload, any restricted user access to arbitrary code to connect to the server. If an attacker uploads executed code.
Oh, you're taking a look at the article.
I'm looking at... Use the default configuration. A post request use the burp default configuration, intercept the post request, and save the setting in burp suite. Rename the file to file dot dot slash. I think it's this actually. Maybe.
Oh, okay,
and then
okay.
We just do.
All right.
Okay,
PH.
well,
Okay. Let's take a look.
if it's that version. Let's see if we go
So
to their
affected-
GitHub.
I mean, there's got to be a file inside of the application that tells you which version is being used, right?
Can we read the README file? Is that still in the box?
I don't know. Let me take a look at the GitHub
Found.
at the GitHub repo.
Not found.
Settings H. Well, I mean, even if we're not sure of which version is being used, we could try this out, right? I mean, the worst thing that can happen is that it doesn't work. But of course, it is better to be sure of the version before we try our fancy hacks. All right, I'm gonna start up Burp Suite. I'll give this a go.
I'm gonna try RFI real quick in the parameter.
Okay. All right.
So when we hit save, instead of using JSON, we just save an arbitrary file and then access it, I guess.
Okay, so we're supposed to hit the filesave.php page. Filesave.php.
Oh, it did reach out and give me a connected. It created a file, but it created out with the options. It's kind of fun. Actually.
Okay, so
that worked. So could we do like curl?
the question I have is, which function in the Dasher application actually uploads files?
It's the filesave.php.
Yeah, I mean, yeah, but I mean, where do you arrive on that? Where do you access that from the application?
But you can reach a file. All right, let's do the CVE first. If that doesn't work, I'm gonna try the other thing. The button on the settings page.
There's a button on the settings page. Oh, okay. Oh, this one. I mean, that's the editor.
All right, so
this is the settings page.
rename the file to. Oh.
Look at burp. Okay, so let's look at burp.
Reset the file.
HTTP history. So I mean, I sent it a GET request by doing direct browsing, but I mean, we could probably just adjust the request to make it a POST request. So we'll just turn this from a post to a get. Oh wait, there's a method we can use to... Anyways. What kind of data should we... I mean, I don't even know what the data is supposed to look like when we upload to this thing. So I'm not too sure. Defa says you'll get the request when you click the button on the settings page. Okay. Let's try. Okay, so the important thing is that we do this in the burp browser.
Okay, now we should have our...
Okay, yeah, okay, Defus, when you're right, you're right. And it looks like you're right. So that made a post request to the filesave.php. Endpoint here. Good. Okay.
And
let's
it didn't
send this to repeater. Ah. Okay. Alright, so what was the rest of the proof of concept there? So it allows for a file to be uploaded to anywhere. If an attacker uploads a PHP file, they can execute code on the server. Default configuration, intercept the post requests used to save the settings in Burp Suite. Rename the file to shell.php. Okay, let's try that.
Okay, well that didn't upload at all.
Okay, so the name of the file... Could it be this easy? Could it actually be this easy?
Does it work on your machine?
Well, I mean, I'm gonna give it a go. Highlight all the stuff, get rid of it, replace it with shell stuff. Is this... This looks like a web shell. Okay, so it's asking us to put in some web shell code. Yeah.
I don't think you can... Well, technically... This would have to be...
Okay, let's see if this works. That gave us the okay. Well, if that's the case, then we should probably go to shell.php. Yeah.
And I just got a shell on my own machine. Good job.
You got a what? You got a shell on your own machine?
Yeah.
File not found. I guess we weren't able to actually... Yeah, file not found. I didn't... File name in the wrong spot. Maybe. Name equals something. Name equals data. Oh, wait. Maybe the name is supposed to be here.
Yeah, there's two names. I saw...
There's... Yeah. Okay.
Oh. Did I switch the wrong value?
CMD equals who am I? Nope.
Okay, I went too far.
Where else would we put this name?
I must have gone too far.
Okay, so maybe this is supposed to be named file. Switch where it says ... setting.json. Yeah. Let's try this one more time. Okay, yeah, I got I got the web shell working. Okay, so I got the web shell working. It's at shell.php. Give it the CMD. Give it the CMD URL parameter. Do whatever you want. I think I'm going to upload a elf binary, and I'm going to get my shell that way. But that's interesting. Okay, let's make a malicious elf binary.
Did you do //file?
Pardon me? I did /file. Yeah.
Kept everything else the same, kinda.
Let me.
I think I need to
Wait. You can see my stream, right?
Yeah.
This is. I'll highlight the part. It's right underneath form data name equals file, and then there's the this thing right here. Do you see it?
Yeah, I'm just. That's a data file. Is it because I didn't give my thing a space? Save this again. Go back to Burp Suite. Send to repeater. Let's see.
Okay. So let's go ahead and
copy.
Okay, so my IP address on the echoCTF network is this. I'm pretty sure. Yeah, that's this one right here. Rick Burns, Hey Hava, would you let me know how to pronounce your name, Hava? Thank you.
Okay, there we go. I just needed to use it with the new request.
And Rick Burns 420. Hello, nice to see you here. Welcome to the stream.
All right, I got it off the different file.
No worries. Okay, so let's host the file, and then let's upload the thing to the target. So I don't know. Let's do Python serve it on port 80, and what does the command give me? So wget the IP address. What's my IP address? Okay, so we're uploading shell.elf.
Nani?
Or I'm uploading shell.elf. I don't know what you're doing.
I'm trying to stop this PHP web server. Okay, good. We successfully stopped it.
Okay, so let's see if the file copied correctly.
So curl.
Oh, nice, nice file name. Nice file name, Oreovite. That's great.
Thanks.
Okay, so shell.elf got uploaded, and the next command is going to be chmod. So what is the plus symbol URL encoded? Is it %b something something? B2 2b? %2b?
%20 is a space. What are you trying to do?
Plus. %2b is plus, right?
It's %2b, yeah.
Yeah, okay.
Thanks, URL encode command. I'm just gonna upload a PHP reverse shell.
Okay.
And then call it. And then we can do music. Quick, get a shell.
That didn't make the file executable. I think I'm just gonna go over to.
We have a shell. Haha.
Darn, you got the shell before me. Anyways, URL encode.
I made my payload really quick
No worries.
with my tool. So.
Have van tow. Okay. Thank you very much for letting me know. Have van tow. All
I
right.
can make your
So
file executable for you.
you don't need to do that. Okay.
Okay, go back to the shared chat. Okay, great.
Okay, let's do that command again.
And remember, kids, don't put in all the flags in if you want to collaborate.
Yeah,
Or
right.
echoCTF will self-terminate, and you'll be sad.
Hold on. Gotta switch up my music again. Actually, you know what? Let's put on some really intense hacker music. Let's see.
Let's see. I feel like my music's super quiet.
Is it?
Oh, there's only 2 flags on this machine. Okay, just user and root.
Okay.
Wow, what a fun privilege exec. Wow. So much fun.
Well, I mean, you know. Okay, I made my file executable finally, so now I can get my reverse shell. And then let's execute shell.elf. Okay.
Seems like you got
All
a
right.
subscriber, or did I get a subscriber?
Somebody got the
Follower
subscriber?
or something. Oh,
Okay, so anyways, I gotta
audio.
call in Mr. Scary Hacker Voice Man because we broke into a system. Just a second.
Hey there, everybody. It's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes out every time we break into a server, and we just broke into this one. Well, Mr. Dasher Administrator, it seems like you're using insecure web applications. That was a big mistake. We found that there was a unrestricted file upload vulnerability for your application, and then we uploaded a web shell, which we turned into shell access. Maybe you knew about these vulnerabilities on your system, or maybe you decided to accept the risk. Well, you accepted the risk. And now we're in.
Okay, error. Hello, nice to see you here. I love mass scary hacker heart. Thank you.
all right. I'm already done with the box.
You already done the box. Was it a lame sudo L Prevesk? Is that it?
I'll let you figure out.
You'll let me figure it out. Okay.
Perhaps.
So which Python 3? There's Python 3. Python 3 command import. Upgrading my shell right now. Okay, so GCC, you say? Okay. So we can just look that up on GTFO bins because it's our favorite website. gtfobins.github.io. If we have sudo access with GCC, what can we do? If the binary is allowed to run as superuser by sudo, it does not drop elevated privileges. This is the payload. So let's drop the payload, but make sure it's a bash shell instead of an sh shell because we don't like sh shells. We're roots. Okay, so that means we can redeem this.
You already put in the final flag?
I'm system root.
No, I need to... So you said there are only 2 flags on the system, right?
Seems like there's only 2.
Well, I mean...
At least that's what it says.
Okay, let me take a look. We want to make sure that... so it says 2 flags, there's user and root. So the user flag is...
I already have the root flag. I'm gonna need some water, so if you want to submit the both, that's fine.
Well, I mean, let me...
If you want to look around for a bit, I'm gonna get some more water, come back.
Yeah, you go ahead and get some water. Let me... Where... So usually the user flag is in the home directory for the ETS CTF user. Yeah, so this is the user flag right here. And yeah, you know, the thing is that it kind of varies from event to event. This event has very easy machines, but some of the other networks, their medium machines are not very fun. But Defus, yeah, you're right. This wasn't overtly difficult. Anyways, let me submit the first flag, and then me and OreoByte will submit the second flag together. Okay. So let's take a look at the web page just for fun. All right. You know, if you were to come across this as a system administrator, you would not be very impressed. So you just, you know, go into your web application and you see all these extra PHP files in here, stuff called shell, stuff to, you know, extra elf binaries just sitting around. You would not be very happy to see that. Okay, so let's go ahead and do the next. You know, the thing about echoCTF is that there's so many machines on this network here. I think there's like 20 something machines, and eventually we're going to come across some ones that are actually really difficult. So we'll see. R.php is a big one. I don't know. What? Oh, yeah, that's the reverse shell, right? Yeah, that's probably the reverse shell that that OreoByte dropped in. And it's a bigger file than what you would expect. So cat r.php. Yeah. There you go. Can't clear, unfortunate. But I'm ready to start the next one as soon as OreoByte gets back. If you guys want to hack on the same boxes that we're hacking on, then you're more than welcome to, as long as we're all on the same page. Because as soon as you submit the root flag, the machine shuts off. But it is really fun to do team hacking, because you can always help each other out, and it always goes by a lot faster. Now let's see, what can we do while we're waiting? I guess we can do our write-up. So let me go ahead and create a little notepad file, and we can start doing our write-up. echoCTF, be our challenges. So this one is called Dasher, right?
Alright, I'm back. It seems like somebody found my file.
Yeah? Anyways, Are you ready to submit that root flag? Oh, the user flag is in the home directory under the.
I already submitted the user flag.
Oh, okay. You ready to submit the root flag?
Yeah.
Okay, 3, 2, 1, go. Okay, done. Let's move on to the next target.
Oh, that's kind of nice. You can submit a flag on any page, and even if you're on the wrong box, it still submits.
Oh yeah, that's nice. Let's do the next machine. So the next machine is Explorer.
Which seems the way at port 80 open.
Okay, and you started it up already?
Yeah.
All right. Might as well go ahead and do that nmap scan. Next box, new B. So it looks like we got port 80. I'm guessing that it's only going to be port 80. That's my guess. Oh, you know what? The name of the network probably gives you a good indication that there's only going to be web applications. So it's called the tag BR network. But anyways, let's give it a quick derb. And then let's take a look at the web page manually. Oh, okay. What are you up to on your side?
Whoops. Oh, just messing up my TMX.
Mm-hmm. So to anybody who doesn't know, Databus, which is the person that's featured on this blog page over here, it's basically the administrator of the echoCTF game. There's no robots.txt file. There's Nginx being used.
If you ever mess up your TMX by doing spacebar by accident, you can go back once by going to command mode, doing select dash layout, space dash out. It'll go back to your previous layout and fix it.
I don't use TMUX. Although I should because people tell me not to use TMUX. Born 1789 and 38 years old. Could that be a clue? $1789, 38. No. It says 38 years of experience. It doesn't say 38 years old. There's a difference. I think this is some sort of resume creating website, or it's like a website that you direct people to when you're trying to look for jobs. So there's a download? No, there's no download page.
You can send a message to the bottom. There's a download now form.
I mean, there's a download? It doesn't lead anywhere. There's a link that says download CV, but it doesn't do anything.
Oh, it just sends you to
Yeah, right. It just sends you to the landing page. Are there links? Designed by HTML Codex, so that might be the software that's powering this. I'm not sure. Anyways,
the only input I think is just
okay. So sorry, I've got to take an ad break. All right, we'll do an ad break for about 30 seconds. Enjoy this woodpecker, everybody. We'll be back in about 30 seconds. Okay, so let's continue. Error says YouTube also runs ads while Twitch ads are on. I just let it play. Awesome. Column Master says, what's what most companies are looking for? 10 years of experience and above. Yeah, especially when you're talking about new technologies where it's impossible for people to have that much experience. It's kind of a oxymoron.
Did Burp Suite not capture the request, or is this just dummy?
So download now. That doesn't go... Let's see if there's anything funny inside of the HTTP source.
Oh, here we go. Right, this is 56, yeah.
Can you see anything funny in that Burp Suite stuff? In that Burp Suite traffic?
I tried to send a request and nothing got sent. So...
So we know that the application that was made to use this is called HTML codecs.
A, B, C.
But I'm pretty sure there's... Well, we'll see if there's anything associated with HTML codecs. Yeah, probably not. Let's see. Ali says, Brum here. Still here for the AES 256 bitcoins. AES 256 bitcoins. Did somebody talk about bitcoins here? Because I don't remember saying anything about bitcoins. Oh, there's So did you do any directory busting on the target, OreoBite?
I was about to start.
So I found an Explorer directory, and the name of the box is called Explorer. So maybe we should check out that directory. Okay, so. Oh, there's an extra application inside of the Explorer directory. Okay. So it's called EXTplorer, and there are known hacks for this application. Have you seen the endpoint yet?
Not yet.
Okay. This is probably the...
Hey, is this running in VMware for me now?
VMware? No. I'm using VirtualBox.
Somebody said from your YouTube stream.
Oh, okay. So Ali says that, right, okay, so you're talking about your bitcoins being locked with AES 256 algorithm. I hope you're able to recover those. I don't think I'm qualified to help you try, unfortunately. And Kieran, thank you very much for coming by, and to everybody on YouTube. Okay, so eXtplorer. Well, I mean, are there default credentials for this application? We should probably just try, like admin just for fun. So admin, or admin password, or admin root.
Did you find it through...
Hey, admin works!
Did you find it through directory fuzzing or some other method?
I just did directory busting with derb. Good old derb. Never lets you down unless it does.
Which is common.txt?
Yep, it's common.txt. Okay, so... Ali says, big love and respect from Pakistan. Hey, we welcome people from all parts of the world here. Welcome, and yeah, let's give you a Hack the Planet.
Hack the planet! Hack the planet! Shut up and get
Okay, so we should probably try to figure out which version of the software is being run. Then we can figure out if there's some sort of known hack that we can use. Oh my god, hack the planet. Yep, that's what we do. You can also switch to FTP mode. I mean, this is such an old application, we might be able to just upload whatever the heck we want. Okay, so let's see. Is there an upload button here? There's an upload button. Okay, let's create a web shell. Okay, so revshells.com. Let's grab the smallest web shell we can. Actually, let's just get the standard web shell. Yeah, this one.
There it is.
What are you looking at?
Waiting for my machine to find the things. Or...
Okay, that's our web shell. Let's see if we can upload this thing. This is such an old... Yeah, like I said, this is such an old application. It's probably not going to have any filters. It's going to let us upload whatever we want. Okay, webshell.php. Let's upload that thing. And it just lets us... You know what? This is this network is really good for making you feel good, because the hacking is so easy today. Okay, let's try to access webshell.php. Yep, I've got web shell access.
Just do this a little off.
And I guess I will try to upload my shell.elf file again. Darn XCOM music is so dramatic. So OreoBite, when back in your gaming days, I'm assuming you had gaming days. What kind of games did you play?
A lot of StarCraft 2.
A lot of StarCraft 2. Okay, the gentleman and the scholar's choice, yeah.
I mean, you say that. And then I moved to League, which was terrible.
Well, I mean, League isn't going to destroy your hands, right? Wait,
kind of, but not the same way.
why am I using a web shell to upload my shell.elf? Why can't I just use the application itself? It's not filtering at all.
So Alhazred was gonna do some League,
Yeah,
but
was
he
it?
decided to play a different game because I assumed people voted for the other game.
Okay, sure.
I thought I originally was going to miss out because I was traveling
Hmm.
before, but then he didn't stream because he became busy or something
Yeah, okay.
in that moment. League is only fun when you play with friends that don't care about losing,
Yeah, okay.
because it's very easy to get worked up. But if you're just having fun messing around, that's okay.
Hmm.
Anyways. Yeah. You can probably guess what character I played in League.
I don't know very much about League. Kieran asked, "Are you in college?" I am definitely not in college. No. Oreobite, are you closer to college age? You're probably closer to college age than I am.
I was in college, but
I also was in
kind of
college
bounced
at one
around.
point. I also graduated from college, yes.
It was college, then test school, then certifications, and now I'm here.
Okay, so make the thing executable and then execute the thing. But first I need to set up my web shell. I need to set up my reverse shell. Okay. But Kieran, no, not in college. Not in college at all. I'm in my mid-40s, jeez.
Is this a joke?
No, not at all.
No, not that. But the thing I'm looking at. Sorry.
What are you looking at? Let's see. Okay, I'm gonna call in Scary Hacker Voice Man in just a second, but first I want to upgrade my shell.
Oh, the thing I'm looking at. Hopefully everything was decently okay.
Okay, so are you on your way to getting shell access there?
I already have shell access.
Oh, great. Okay, so I can call in Mr. Scary Hacker Voice Man again. This is gonna... I hope we don't get too many of these boxes because it's gonna destroy my throat. Okay, so let's do...
Hey there, everybody. It's me, Scary Hacker Voice Man. We're back for round 2. Well, Mr. Explorer Administrator, it seems like you're using applications from the 1980s, or at least that's what you would assume by looking at this silly manager app. We managed to break in by using default credentials, and then the upload function didn't filter anything at all. Maybe you probably knew that your security was really bad, but I guess you accepted the risk. Well, you accepted the risk. And now we're in.
Okay, so, hopefully, well, we'll see. We'll see if the privilege escalation is not really dumb. It's really... It looks like it could be really dumb.
Well, however you use that, I have no idea.
Um,
Surprise!
Yeah, I mean, I've never seen this application before. So...
I don't think I could do anything with that.
What is this file? So it's a root-owned binary?
So, for the rations, thanks for the follow.
Okay, so we don't know. It's probably a binary. Or...
Well, it has a help menu, but it says API and restart and stop. Not PSOX. Yep. There's a service running on. Unless that's just our.
So let's see.
Sock,
Usage.
unless that's just our reverse shell part.
CLI and so command line interface entry point. So show slow generator version. I mean, what version of this? Let's do some research.
Maybe it's just our reverse shell sockets.
Okay, so what is slow generator? Okay, so it's a tool to compute and export service level objectives. Ah, okay. So I see a known hack for slow generator. So the first thing we need to do is get the version.
I'm tempted to find an alternative method.
I'm just gonna go for the low-hanging fruit. Well, I mean, yeah, I mean, you know, if you wanna...
Cheese.
So we've got a known hack over here.
It's running Debian 11.
Okay, so save the below YAML code in a file, so exploit.yaml, okay. So let's go ahead and, well, I'll move into the temp directory to do this. Okay, so Kieran says, quick question, do you have a desktop? Do I have a desktop? Yeah, I'm working off of a desktop computer right now, if that's what you're asking.
My shell just exploded.
I'm still
Your shell.
I'm still here. I'm still on the box. Did you do something specific before it kicked you out?
No, my shell just froze.
Did you use a PHP reverse shell?
Yeah.
Okay. Let's see. Slow generator migrate B. Right. Okay. Let's try the prescribed payload here. Oh, we need a password. Wait, why did... Oh, okay. I think the reason it's asking for a password is because I didn't give the explicit file path. User local bin slow generator. Oh. I think there's something wrong with the payload here.
Was it getting stuck?
No, the payload uses Python, and the Python is showing a bunch of errors when I run the payload.
Is it because it's in Python 2, not Python 3? Because Python 3 is installed, but not 2.
Could be. Could be. Let's see what we have here. How else could we do this? I'm still getting a bunch of errors here. So how do we do
Python
this?
object OS system apply who am I? Could we just... Are you talking about this one?
Well, I mean, I'll point you at the one that I'm looking at. So I'm looking at something from EDB.
I'm looking at something on GitHub.
Oh.
Nano's not found. Okay, fine. We'll do cat to test.yaml.
But I'll take a look
file, and we're done. Wow. And now we can do.
Wait, did you follow the one from the GitHub?
No, I was just. If your not video editors, if your file editors are not installed, you can cheat with an end-of-line file cat, where you end-of-line file all the lines and then type end-of-line at the end, and it pipes it onto one file.
Okay. So I'm pretty sure that the file that I linked to you and the GitHub one that you linked to me, this all looks kind of
the same.
Yeah, I think these are the same, but sorry, how did you fix it?
I haven't tried it yet. So hold on, I'm like about to try it. So oh, it's set env. We need to do variables, like Python variables. Sudo.
Sorry, I don't follow. Could you explain that one more time?
The sudo-l is set env. Is it like Python set in path environment variable hijacking?
Oh, really? Okay. Wait, what
is
is
it like that, or because in the sudo-l you have set env set to no password.
Sudo
I'm just not sure. Yeah.
Set
I just saw
env.
that.
Oh, okay.
I'm not sure if that's required or not. I'll try this.
Set env, no password.
YAML has been removed to use. Does it have to be Python? Vim is also not installed. Awesome.
So
Okay,
which
well,
vi, which vim, which
time to choose yet.
which nano? All right. Well.
Yeah. Oh. Actually. Choosing. Later.
Okay. So I'm not exactly sure what's going on. I'm gonna.
Okay, let's do the error. Let's see.
I'm going to ask about this error from my good old friend Claude AI. See if Claude AI knows what's going on. Oh, what is the...
What has been removed?
Okay, so the YAML library...
Instead of...
Oh, okay. Option 1.
YAML water subject to objection. Oh, that's not what I meant. Not the only one this list of... Not that one. This one. Okay, well that reloads again. We are going to see if these do anything. I hope this isn't a part of like their setup stuff.
What?
I'm just trying some Peter stuff.
Oh. Sure.
In the background.
Yeah, alright.
Well, I think of a better way to do this. Yeah, it's the only one. Oh, I could have like changed the thing. I'm really smart.
So, I mean, you're probably right that the... I mean, my guess is that the set env has something to do with how we do the privilege escalation.
I could actually like attempt to change what it's getting run to. That would be helpful. So. Try this. Echo.
You can set environment variables.
Cat. YAML. And the file. And then. No. That does exist. Okay, cat and the line file. I don't know that YAML.
Hmm.
And then it's getting stuck, isn't it?
Okay. So...
Man, I love it when it gets stuck.
All right, so set. So when I talked to the AI about the situation here, it suggested something about Python path hijacking through the setenv variable that we have with sudo?
Yeah. I'm just testing this for fun. Doesn't seem like this is working. The other thing, not the
So see, so the slow generator binary, which Python module is it using?
well, it's using Python 3.9, whatever module it's using, I have no idea.
Okay, so it looks like it's... Let's see.
I mean, it's using migrator.py in the error message.
Havane2 says,
And it's
let's
using...
see. Is there any difference between the two OpenVPN downloads on echoCTF? I think one of those VPN keys uses a newer version of OpenVPN, so you should probably use the later version one. That's my guess. Click dot. Okay, so, I mean, the AI is suggesting that we create a malicious Python file and then set the environment variables to point to the directory where that file is. I'll give it a go. Okay, and then what is our IP address? Okay. And so what fun are you getting up to, OreoBite?
Oh, right, I can't do that. I keep forgetting that all the file editors are not here.
Well, I mean, you can, if you want to write a file, you can just write a file on your own machine and then upload it, right?
I'm just abusing a line file right. Very carefully.
Okay. I got root access.
Oh. Add file.
What are you?
I'm system root.
Sudo path equals
Chloe Anderson, hello, nice to see you here, and welcome to the stream. Welcome, welcome. Let's give you a fun hack the planet, because that's what we do.
Hack the planet! Hack the planet! Shut up and get
path equals path and then do this.
Okay, so let me just gather some notes. Hack the planet. Yep, that's what we're doing.
And my shell broke.
Arise Heart asks, are you going to do the Google CTF just through a click module? Dang. Sometimes the hacks are like that.
I love breaking my shell.
Okay, so let me go ahead and get the contents of the malicious file. Okay.
That did not do anything. Sweet. No cheesing. Unfortunate.
Alright, so how do we... SLO generator. So the actual privilege escalation didn't really rely on the version of the SLO generator being used. So it requires Python. It requires Python 3. I guess... So I guess we can take a look at the So SLO generator requirements pip3 So my question is, the SLO generator, how do we know what imports it uses?
Did you get it from the error message?
I mean, I got it from the error message, but I wouldn't have known to use the... I guess that's part of the intended way of figuring it out, right?
It wasn't from core generating my grade.
Well, The malicious file that I created was called click.py.
I tried to use my migration, my migrator didn't work.
Okay.
That seems to run core first.
So migrator.py, CLI.py.
That did not work.
None of those worked, but
No, I tried to migrate it by itself. It didn't work.
okay.
Copy.
You can try some other file names.
Sudo path equals.
You know, I'm interested to know why the AI knew that how the AI knew it was supposed to use click.py, because I don't see click.py in the error output here. Okay, let me get my flags.
Okay.
Let me get the flags.
Okay, maybe I need to change up my my payload. Oh, I made the same mistake again. No.
Okay. Oh, you're working inside of the home directory. I see. Let's see. Is ETS CTF a CTF running at the moment? No, it's not a it's not a CTF running at the moment. Arise Heart, hello. Are you going to do the Google CTF? I've never done the Google CTF before. How about you, OreoBud? Have you done that before?
I think I did once, but I don't remember if it was with anybody as a team or by myself.
Okay.
I don't remember.
But Arise Heart, I don't think so. Nobody's really brought it to my attention. But let me look that up. Google CTF 2025.
Alright, do this right.
Google Capture the Flag 2025. Google CTF. I don't see. Okay. Google Capture the Flag 2025 official rules. So this is going to be in October. It's kind of a long ways off. It's live right now. Really? Hold on. If it's live right now, let me know. Give me a rough idea what I'm supposed to search for. Oh, okay. So the qualification stage is June 27th. Oh, that's today. So June 27th to June 29th. Okay. I don't think you can leave links in YouTube chat. You can leave links in Twitch chat, but YouTube chat I think is not gonna. Yeah, just go on CTF time. Okay, so CTF time. Google CTF 2025.
Oh,
Yeah, it's
also,
running.
I'm using the wrong argument.
Okay,
I'm
so where's the link? Oh, the official link is over here. All right, Google Capture the Flag. Yeah, it's on right now. But I think somebody else was asking about, is echoCTF something that's running right now? No, it's not running right now, and if it was running right now, I wouldn't be able to live stream it, because they'd probably have some rules against live streaming live events. So if you see people doing CTFs, they're probably not doing live CTFs, because otherwise they could get disqualified for live streaming it. Just to let you know. Okay, so let me try asking the AI then. Okay, so how do you know the click.py module was the one to target. Does it appear in the error outputs?
Migrate.
Okay, so you're absolutely right to question this. I made an assumption that wasn't fully justified by the evidence.
Did you have to give it a fake YAML file?
A what? Did I have to give it a fake YAML file?
Yeah.
So the
And I got stuck again.
So the hack that I used didn't. The hack that I used just involved using a fake. It used like a malicious Python file.
Keep killing my shell. That's not what I want. Girl. Did you figure out
Chloe Anderson. Chloe Anderson is subscribed on YouTube. Thank you very much for the subscription, Chloe Anderson. Welcome to the HackerFrogs. And let's give you a fun video redeem. How about a woodpecker? A woodpecker, the northern flicker.
That's what I do. Core.
Okay, so
I suppose I didn't chmod the file. That should not matter.
with the Python file or the you don't need to switch the file permissions on the Python file. Yeah, there's no strace though.
File. Run the attack.
Lembo! Hello, nice to see you here, Lembo. How are you doing?
Import our social system.
Okay, so let's see. Check what's actually being imported. I'm just trying to understand which slow generator dependencies we should be targeting with this. I guess if I could take a look at we could take a look at any one of these Python files and just take a look at the imports. Oh, okay.
I keep hanging my shell, it's getting really annoying.
Alright. Alright. So I think it's starting to make a little more sense. So I'm taking a look at the actual Python files that the slow generator is running, and it's got a number of different imports.
You just set the Python path to whatever directory, right?
Yep, the directory where your malicious Python module is.
Why is this not working?
Yeah, so there's import click here, but there's also import logging, import OS, all this other stuff. So we should be able to do it with logging.py as well. Let me give that a try. And Blue Bubble, I see you here. And Blue Bubble, what are you up to? We're hacking all on a Friday night. Lots of fun. Okay, so let me get out of the root shell. And we'll just copy click.py. We'll call it logging.py.
Do you have to give a valid YAML file?
The payload I use doesn't use the YAML file at all.
Or was really?
Here, this is the command I used. I'll leave it in the group chat.
I'm trying to migrate a file that doesn't work.
I'm not
assuming that it'll run the core part.
I'm not using the YAML
That is
file.
not working.
I'm not using the YAML file at all.
You're just using it to like run the rest. I tried using the help and it froze my shell. Or, well, I did a lot of different things that also froze my shell.
Okay, I'm gonna try. Hold on.
Copy core.
So let's delete. Let's
Ran the help.
delete the
Copy.
click.py file, and we'll try running. Yeah, okay. So you could use any of these modules, as long as it's one of the modules that's loaded in by the slow generator. You could use logging, you could use OS, you could use system, you could use time. What happens if you use... Let's see if we can use time instead.
But bin bash won't get set you ID'd. Hey, that's the command.
And let's run... But time didn't work. That's funny. But if we try logging, it works. Yeah, this is interesting. This was a more interesting challenge than the other challenge we did tonight.
Okay, I'm just trying to think of what I could use that's more stable and reliable.
Okay, so let's do a little write-up on how we solved this machine. Okay, so there's only port 80 open. And through directory busting, we found there's an Explorer. There's an Explorer endpoint.
Do you submit the last flag?
Pardon me? No, I didn't submit it.
Oh.
Did you get booted again?
Oh.
Wait.
Yeah.
How much time do we have left on the machine?
No idea.
Let me check.
Never mind, I'm back in.
Oh, we got 18 minutes. Let me submit the user flag, so we get a time boost.
Did I not submit the user flag already? Yeah, I already submitted the user flag.
But you know, what don't you understand about how the exploit works?
It's not that I don't. It's not that I don't understand. It's just that I'm messing something up.
Okay, so at the Explorer endpoint...
Just because you have the right idea doesn't mean you can still mess it up.
No, I totally understand, because even though I know... I like to understand exactly how the hack is going off, otherwise I don't feel good.
I was trying to be simple and just set bin bash a set ID, and then it didn't work. So instead, we're just going to try to do a reverse shell, please.
Okay, so
Just
what is
did
the
that.
name of this old application over here? eXtplorer.
That didn't work.
App has unrestricted file upload functionality.
Why is Python path not working? Echo export path is equal to
Okay. We have the following sudo permissions.
use a dash help.
Yeah, I did dash help.
Just a dash help, huh? What?
Okay. And
I'm so confused. You did core CLI and migrator. You put some type of Python something.
so
You did
so
Python path equals blah.
Python path.
Uh-huh.
So sudo, what was it?
I feel like I'm losing my mind.
Sudo Python path equals whatever directory, and that's the Python path where it's going to be looking for its module files, right? We run the slow generator and we run the help. When we run the slow generator, it's going to import everything that it would import in its normal operation, which includes files like click.py and logging.py, and if one of those has malicious code in it, it executes the code on import. So
Maybe you have too many files. They're fighting each other.
which directory are you using for your malicious files?
Now I'm using dev sysgem.
Okay.
Oh.
So why don't you? You could move into the temp directory and start deleting my files. It's fine. I'm already done. Okay.
Why
this
does
means
it not want to run?
we can set the environment variables
It works, right? Python 3 core.
for Python, which includes which directory it imports modules from. We need to know which Python modules it imports. In this GitHub repo, a lot of info about the tool.
I'm questioning if my writing, how I'm trying to write the files to the box is breaking everything.
What do you mean write the files to the box? How are you doing it?
Because I'm doing an end-of-line file, I don't know if it's breaking it. But then, like, that file ran perfectly fine, so I have no idea.
Why don't you try uploading the files instead?
I don't understand.
Try uploading the files instead. It might work. There might be something funny about the way you're executing commands.
Works.
Okay. So this indicates to us that we should...
I was getting typo bugs, so I was trying to not do that.
Okay, great. So I've got my write-up all written up.
And got stuck again. Yeah.
So do you think we can do the next box in about 30 or 40 minutes? Zimu. Zimzu.
Was the root flag a catable file or is it just a listable file? I can't
It's the
forget
name. The root flag is the name of the file. Zimzu says, "Hey, dude, I have a question. I've been creating my own Roblox level 8 executor. I've been found out how to run the execute function and the inject function. Execute function and the inject function. Are you talking about using Roblox as a form of malware? Because I don't know anything about that. I've never really used Roblox before. But let me know what you mean by that. Thank you. And welcome to the stream." Let's see. They also see. Zemzu also says, "I've found out how to run my own Lewis state in the WebView 21." WebView 21. I'm not too sure what that is. Let me look that up. WebView 2? Is that what you're talking about? I'm not too sure what you're talking about. But there's a lot of tools and software I don't know about, because it's kind of impossible to know all of them. Okay, so do you
Do I what?
do you mind if I spin up the next box?
Go for it.
Okay.
What do you have in your file?
What do I have in my file?
Is it because I didn't use logging.py?
Well, it only uses specific names. So it's it's either logging.py or it's click.py. There's a few different ones that are loaded in. It doesn't load in. It doesn't load in all of the.
Oh,
all
now
the...
it's okay. Now it decides to work. Whatever. Fine. Rude.
What was the issue for you?
I guess I needed logging.py for some reason.
Yeah. Cobblemaster says, "Did you solve the previous box? Sorry, I was AFK." So what was on the previous box? Because we just solved our current box over here. Okay.
Anyways,
You ready to submit the flags?
Hold on. This is sloppy, but we're...
Just let me know when you're ready.
I am ready.
Okay, 3, 2, 1, go. Okay, so that one's done. That was more fun than the previous box. At least the privilege escalation was not super easy. It was.
I always I was right about the ENV part.
Yeah, I mean, you wouldn't see something like that without it being relevant. Okay, so let's move on to the next box. Maybe we can solve it in the next 30-40 minutes. So the next one is called moderators. Let's
Okay.
Zemzu says, do you know anything about dynamic library languages? Dynamic library languages. I'm not much of a programmer. OreoBite, do you know much about dynamic library languages? Oh, dynamic library languages. I mean,
DLLs.
Dynamic libraries are like DLL files, right? Dynamically linked libraries.
I should know, but I am blanking super hard.
Okay.
All right, we have 22 and 80.
Oh, yeah, I haven't, I forgot to do my nmap scan. Let's do that right now.
When I think of DLLs, I think of, like, payload creation and... Alright, hear me out.
Yeah.
So, .msi is usually associated with the always elevated privilege escalation technique.
Okay.
Every time it's mentioned, usually you use Venom to create the file.
Yeah?
What
okay.
if somebody made a box where Defender was enabled, you couldn't use Venom because... What row? Defender is enabled. I would be very interested in how people create the MSI file from scratch.
Well, I mean, is there not a box that's kind of similar on something like HackTheBox?
I've never seen a box with that privilege escalation method with Defender enabled. I've tried to cross-compile it, and it was a mess.
Okay.
Never figured it out yet.
All right, let's go ahead and manually investigate this website.
Row 44 or 444. This will follow. I'm juggling only 2 screens, so sorry if I'm missing.
Okay, so I mean, it looks like some sort of blog site. Oh wow, we got potential usernames.
Oh no. You say usernames?
I don't know. Elmexicant says, "What's your opinion of TryHackMe? I use it to learn about ethical hacking. And I wanted to know if you know where I can get better at hacking. TryHackMe is a good place to start. PicoCTF is another good place to start. Elmexicant, let me know what your previous experience is as far as hacking is concerned, or like technology stuff. Do you have experience with programming or web development? Let me know, and then maybe I can give you a better answer."
The question is, what do you want to learn? If you're starting out, TryHackMe is great.
So I'm just collecting some usernames over here.
I got started on TryHackMe. There's no best platform. There is what you want to learn and how could you accumulate all the different ways to do the same thing. TryHackMe, it might have method to do something one way, but like HackTheBox might have a different way of doing it. Both are useful.
So
No
LMScan
experience,
says, yeah, okay. So no experience with programming languages except for scripts that I've messed around with in games. Recently, I've started learning Python. So I think if you're coming at it from like a very beginner perspective, the best way I would say TryHackMe is pretty good place to learn, and echoCTF. I can give you a echoCTF list, like playlist, that I recommend to people. And let's see. Over here. There you go. So if you find that the challenges over there are way too easy, just skip the really easy challenges. The challenges do get more difficult as you go on. From that playlist there. Okay, so what are we doing? What are we up to? Yeah, there's that blog, right?
There's a login that doesn't go anywhere. That's cool.
There's a login page that doesn't go to a login page.
Yep.
Okay, so we got a list of usernames. That's great. What can we do with this? Are there any obvious links? There's an about page, there's a home page, there's a team page. I don't see any other links.
Okay, let's see if that just works.
This stuff doesn't go anywhere. The login button doesn't lead anywhere. Okay. There's probably like a backhand somewhere, right? What? Hey, Oreo Bite.
What's
up? What funny thing do you notice at the end of that URL right there?
The about page.
Could it be looking for some sort of URL parameter?
But it's an HTML page.
I mean, I don't know why the question mark would be there then, right? Oh, okay. You want to make sure you're not missing any of the basics. Yeah, let me give you a list. Okay, so there's in the list that I sent right there. There's going to be there are two links for IT basics, and then there's one link for computer networking. Try looking at the link for computer networking. It's a course playlist for the Network Plus certification, and you learn a lot about computer networking in that course. It's done by Professor Messer, who I recommend highly for learning about these technical topics. And each one of the videos is not very long. They're usually under 10 minutes or so. But it's really good information for learning about network hacking stuff, because you got to have that computer networking background. IMAX Operator, hello, nice to see you in YouTube chat. Welcome, welcome. Okay. So let me see if I found anything with my directory busting. Not yet. Tommy Coart. Tommy Coart is just subscribed on YouTube. Thank you very much, Tommy Coart. Welcome to the stream. Okay, so we got a JS endpoint. Well, I mean, is this going to be brute forcing? We've got a bunch of
trying that.
What do you say?
I'm in the middle of trying that.
You're in the middle of trying that with all of the usernames that we found?
Usernames with a altogether lists from the website.
Okay. Let me see if there's anything... Yeah, the login page doesn't go anywhere. The team page... Let me... Okay. You know what? There's information about the challenge on the echoCTF page. Okay, so on the echoCTF page it says everything exists in the open unless it's secret. Be vigilant. Note, even if you walk to the help desk and shout, yell, or beg, no hints will be provided for this machine.
Huh? Scream and shout.
If you walk to the help desk and shout, yell, or beg, no hints will be provided for this machine. Well, I mean, I don't think very many people have gotten the flags for this machine. I guess we could check. So, yeah. This machine has only been rooted 6 times.
We're getting the question mark when you enter an email.
Okay. Tommy says, that's me. I thought I was subscribed on YouTube. Thank you very much for the subscribe, Tommy C06. Thank you. Okay, so what are we doing? Yeah, I mean, Okay, so, Gervin. Now, Mexicant says, I don't know why, but something about the URL param in the HTML page has got me curious. It's, yeah, it is weird.
It's only 6 characters difference.
Oh, you know what? I think...
What?
So, when you click on the login page, this is what it leads you to. And I guess this is just part of the, what was it? The single page layout that brings you to different parts of the main page, right?
Yeah, but about home are still valid pages.
Yeah.
Because if you click on the home page and you click on the login page,
Mhm.
it just gives you a hashtag. If you click on the about page, there's nothing unless you hit the subscribe button, and then the subscribe button brings you to the page and gives you the question mark, with also the @ sign.
Let's see, Zemsu says, this looks very interesting what you're doing. It's a bummer that you don't know much about programming, as I've been studying and getting into reverse engineering. I mean, is there a robots? No, there's no robots.txt on here. Okay, so I mean, what languages are you trying to reverse engineer, Zemzu? Yeah, I would have told you immediately if there was, Ariful, nice to see you here. Lua. Okay, you're trying to do reverse engineering on Lua. Well, I mean, I'm not... I mean, in general... So if you're, you know, if you're looking for beginner cybersecurity education, try HackMy's pretty good. If you're looking for reverse engineering stuff in particular, that's tough. Let's see if there's much in the reverse, in the reversing. So reverse engineering. I'll give you the search page. You might be able to see some stuff that's relevant to you on the page. Maybe not, but I mean, I'm definitely not very good at reverse engineering. But OreoBite, if you were looking to get into reverse engineering, which platform would you go to?
Other than the like sub challenges on CTF platforms like HackTheBox or other.
Well, I'm thinking more like an
dedicated
education,
like
an education resource.
I do Pwn College. Pwn College is where you wanna go.
Pwn College. That's a
Pwn
good.
College is
Pwn College all the
free.
way. Yeah.
Free. Pwn College is not only reverse engineering but also binary exploitation.
Yeah.
Pwn College.
So Pwn
College is where you want to go.
That's where you want to go. The problem is that I can't cover any of this. We can't cover any of the stuff we can on that stuff over at over on our live streams because it's not allowed.
If you solve all the challenges, they'll send you a nice fancy belt, kind of like martial arts.
Like a martial arts belt.
A belt for like your level at Pwn College.
So you can show off in front of all your hacker friends. Okay, so yeah, this isn't going anywhere.
Change that.
Wait, do you think any of the usernames could be used as endpoints? A virtual belt or a physical one? Is it? Yeah,
physical.
It's a physical belt, huh? Okay.
Right.
Versace Gorilla, hello, nice to see you here on Twitch. Welcome.
Hold on, let me double check those. Pwn College.
Okay, let's try some Ferrex Buster for some overkill.
Yeah, earn your belts. So I'll have to ask my friends because I know somebody completed one of the levels.
Oh yeah?
But College.
Okay, Roadless Traveler says good to be here. Hello, Roadless Traveler, and Jatin, hello, and Mohammed. Would we appreciate if you could create a list of useful platforms for CTF and learning? Thank you. Yeah, well, you know what? I think we've been working on a list like that, and I think we'll be publishing something pretty soon. Zimzu says, I've also heard that Unknown Cheats has some good reverse engineering techniques. Unknown Cheats, is that... Unknown Cheats.
Aha, here we go. Here's my proof. 2 years ago. Fuck.
What?
This person got their blue and their yellow belt, and look, it's on their desk. Potent college belts. Aha.
Okay, so
There's
I mean,
my
this
evidence.
is the website right here. Okay, it's a forum. Okay, well, I don't know if this is legal or not. If it's not legal, then I apologize. But there's the there's the forum link. What were we
Anyways,
doing?
yeah. They'll send you belts
Mm-hmm.
once you complete it. Alright, any ideas? Because, Hydra's not getting me anywhere.
Bilal Woods has just subscribed. Thank you very much, Bilal Woods. Thank you.
Juice LMFAO, thanks for the follow.
LMFAO.
Juice LMFAO, what a great name.
Yup. Yeah.
L Mexicant 8028, thanks for the follow.
Okay.
Hello. I'll
All
definitely roll if I go to DEF CON. DEF CON is soon.
DEF CON is soon.
It only costs you $560.
Only.
Not even for the hotel, just for the ticket. Who wants to conspire to do the...
Wait, did you say $560?
Yep.
That's American currency?
That's right.
That's kind of steep. I'm not gonna lie. That's not the cheap ticket you'd expect.
Cha-ching. There's your evidence.
Yeah.
$560.
Okay. I wish I won that DEF CON ticket from TryHackMe then. All right.
Yeah, there's a bunch of that.
Okay, Jatin Jagadisha has just subscribed. Thank you very much. Welcome to the HackerFrogs. Okay, so let's I haven't thrown directory list 2.0 whatever at this thing yet.
If you share a hotel with your friends and get it through the con website, it's not that bad. That would be around, like, depending on how many days you stay, could be like $200 a person or something like that. Like 250 about. Or a little bit more, a little bit less. The biggest expense is the hotel, getting there, food, and the ticket. Everything else is up to your own choice. Let's go to the vendor hall and spend all of our money buying books and stuff. But, yeah. The price keeps creeping up, and it makes me kind of sad.
Oh yeah? Okay, so let's catch up with chat. LFI Leafhorn says, too costly hotels, manageable. Manageable? Time to bribe some friends of mine then. If you know people who are going, and yeah, maybe somebody could sneak you in for free. If you can sneak into for free to DEF CON, then you're a real hacker, right? Is that
Unless you volunteer. I've heard that supposedly if you volunteer at some places they give the volunteers badges, but I'm not 100% sure of who or where to look for that. I don't know, become a goon, help out with the con.
Yeah, I mean volunteers usually get something, right?
I volunteered at other cons, just not DEF CON. Anyways. I guess we could fuzz the one parameter that doesn't go to anything.
I mean, it's an HTML parameter. I don't know if it really if it really does anything.
I feel like the meme of the poking the stick. Do a thing. Do something.
Yeah. Okay, so there are a bunch of PNGs here. Maybe plug the names into. Yeah, I've tried the names as endpoints, as names of endpoints that didn't really do anything.
So maybe we can do. My team got sponsored for a school, thankfully, to go to DEF CON 33. Let's go! That's awesome.
Huh. What?
Okay, how can we do this without breaking the website? Maybe. Yeah.
Okay. I have not too sure where we should go from here on this box. What's your feeling?
I'm just trying to. Well, the Hydra is still running.
Okay.
I don't know if we're supposed to use Rocky. I don't know if we're supposed to crawl the website. I don't know if the username is equals to the password. Like, if we take all their odd aliases and set that to the password, or is their username the password for their username that we have to query as a username list? So, kind of just. Basically trying to. Okay. All together. Kind of just waiting, a lot of waiting.
Yeah.
Doesn't seem like setting that to the endpoint did anything.
Yeah, I mean, LMX Cants asks, is there an admin page? Where's the site? What's the site version? I would take a look at it if I haven't already. Well, I mean, we've been looking for some sort of hidden directories, but we haven't been able to find anything.
Unless, like... Well, let's see. So...
There's no straight-up admin directory or anything.
Okay, that's something you should read. As I cover it with junk. Cool.
There's a version of Nginx, but I'm pretty sure Nginx is not vulnerable in this case.
1.18.0.
No.
Exploitus. That is not how you spell that. Oh, there it is.
Okay.
just give me a bunch of services that are not running on this machine.
Okay, let's
Go back to... Well, I guess we're gonna wait patiently, because I'm not sure.
Did the machine go offline? What's going on?
Doesn't no, everything's. Oh, am I scanning too much now?
I don't know. I don't know. I'm trying to run my Nikto scan, but it's not going through.
Let me turn off the derp scan. We'll have 2 Hydra scans running at 4 threads each, and then we have one Ferox Buster running at measly 5 threads.
Yeah, no, I've got a Ferox Buster running as well. Maybe I'll turn that
How
off.
many threads?
Default.
You're running at 50 threads.
Okay, my Nikto scan is running again. Great. But yeah, I turned off the Ferox Buster. Thank you very much for following on Twitch, Monkey Bones. Thank you very much. Welcome to the stream. And you know what? Let's give you a fun video redeem. How about the frog song?
As not is for HTML.
Okay, so the hint for this machine is everything exists in the open unless it's a secret. Be vigilant. That doesn't help us at all.
Yeah, the usernames.
Everything exists in the
they're
open.
just leet speaked and they're just normal letters.
What, are you talking about converting the leet speak to normal letters?
Yeah,
I don't know, maybe.
That'd be kind of silly. I should have used potato.
Potato?
Potato. Potato. Or potato. That's not how you
Potato?
pronounce it.
It's like, it's patator, right?
Potato.
Patator. Patator.
Or predator. I don't know.
And something. Okay.
Basically, it would be way more verbose than Hydra. Oh, I guess we never figured out if SSH requires keys.
This one?
Yeah.
I mean, you can manually test it out right now.
Maybe? It's not enforced. But...
Yeah. I mean...
it's giving off the same message as the one that had a key in it.
So I'm... You know what's funny? I'm pretty sure that this might be the system with the least amount of the least amount of roots. This is tied. This system that we're taking a look at is tied with 4 other boxes for the least amount of people who've rooted it.
Even though it's intermediate.
Yeah, even though it's intermediate and the other ones are difficult, apparently. Expert. Not that that's an excuse or anything.
I mean, if this is try hack me, you'd be able to throw
Through what?
more threads at SSH.
Oh, okay. Well, I mean, you can try solving this over a few days.
I feel like it's gonna turn into one of those where you take a nap, you wake up, and it doesn't find anything.
Yeah, well, I mean, I've had that happen before. Okay, so another thing for this challenge is there's a little description here. It says, you see everything except secrets, and you find everything except treasures. Have I checked vhosts? I'm not... I mean, we don't know what the subdomain name would be. There's nothing here that indicates there's a subdomain... there's a domain name in place.
Unless it's moderators.echo, it should be...
Yeah, okay. I don't know. I mean, in that case, they would give you some sort of hint somewhere in the source code, right? I'm gonna check the curl output to see if there's any weird headers. Okay, so no weird headers.
You don't think there's metadata in the textures, right?
Metadata, were you talking about inspecting all the pictures?
Yeah.
I really don't want to inspect all the pictures. Diva says the last offensive con entry ticket was what? 1,500 euros? Who can afford to go to a con that charges $1,500 for a ticket?
We don't really have a vhost to use.
What'd you say?
So, did you already answer somebody vhost?
A very rich hacker is the answer. vhost, yeah. I mean, we don't know what domain to use. That's the problem. We could do some vhost stuff, but we haven't been given anything. So I mean, considering the amount of people who have actually finished the box, I don't have very much confidence in our ability to finish this.
Oh, come on!
In the next in the next few minutes, anyways.
Do you need to jet?
Well, I mean, I should probably end stream pretty soon because I don't want to bang my head against the wall and then, you know, suddenly look up and it's like 11 p.m. or something. You don't need to drop your Fs in chat. It's fine. But I think I will be looking for somebody who to raid. No, I don't need to look for anybody to raid. OreoBite is here. OreoBite, how much longer do you think you're going to be keeping at this?
Oh, keep going a little bit longer.
Okay.
Yeah, it doesn't seem like there's anything in the metadata other than the fact that it was created on a Windows box. Which is funny because I think all the boxes on Echo are Linux.
Yeah, I mean, as far as I know. Okay. So I found the way to game the system where you can get people, you can entice people to watch your videos based on the thumbnail, right? I've got my bird, I've got my bird videos, and the birds are super cute. So I'll just put the birds on.
Oh, different
birds, right? Yeah, different birds.
Versus the last thing you said.
Yeah. And this way, I don't have to feel scummy. But yeah, let's go ahead and plan that raid. We're going to be streaming next on Monday, because that's when we usually stream on Mondays, and Friday. When I can't talk anymore. Mondays, Wednesdays, and Fridays, and we're going to be getting up to a lot more hack and fun. Please look forward to that. And you know what? Let's go ahead and set up that raid. Okay, so yeah, so be back on Monday. I hope everybody has a great weekend, and we will see you next time. HackerFrogs out. And everybody on YouTube, thank you very much for coming by. Let's see if we can find somebody to raid out to on YouTube. Oh, sorry. Let me end the call with collaboration call. Thanks a lot, Oreo Bite. See you next time.
Collab.
Okay, so I think here's the thing. There are not very many people who do live streams for. There are not very many people who do live streams for cybersecurity, but I'll try to look for one. Okay, so on YouTube, I'll search for. I don't know what I'm searching for. I'm gonna search for live, and then inside of live, I'll look for cybersecurity. And there's a oh, Henky Lodwig is on. I've seen Henky Lodwig in chat before. Let me see if I can raid into them on YouTube. I'm gonna yeah. Let me try. Hold on. I swear I can get this working. Okay, so customization, redirect, yeah, and hold on. So redirect. I don't know if I can figure this out. I'll get this redirect thing eventually. But everybody have a great weekend, and we'll see you next time, okay?